Hi everyone, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. And students, today we are going to do hydrocarbons chapter, and you will see that a lot of important questions are asked in your JEE mains as well as JEE advanced. Okay, so firstly we are going to finish the theory part of alkanes and alkenes, alkynes and aromatic hydrocarbons that we will do in the next part. Now, out of alkyne, and aromatic hydrocarbons, a lot of questions are asked, but the most important part is alkene, the chemical properties of alkene. From there, a lot of questions are asked. And the second important part is alkynes, right? The properties of alkynes, the preparation of alkynes. From there, also, a lot of questions are asked, right? But if you feel that, okay, I can skip hydrocarbons, that is alkane part and aromatic, no, because a chain kind of reaction are asked, and maybe they will ask you A, B, C, D, E, F product. What is D product? What is F product? Right? So you cannot skip any of these because a chain kind of reaction can be asked here. Okay, so everybody in the chat box, hi, Nakiran, Pavan, Varshit, RK, Girish, everybody in the chat box if I am visible and audible. And also, if I am visible and audible, let me know in the chat box. And also, I want to see your energies in the chat box. Okay? I want to see your energies in the chat box. Let us see how excited you are for this chapter. Right? Okay? Yes, everyone? Very good, very good, very good. Now, let us start with this one. Just give me a second. Okay. Let us start the haloalkanes and haloarenes. Okay. Good evening, ma'am. Let's start. Let's start. Yes, let's start. Okay. Chalo. Now, starting with firstly, we will start with alkanes. Firstly, we will talk about little bit of alkanes, what are alkanes and all of that thing, right? But not in that much detail we will talk, because this is a very simple thing, right? Just a recap of the thing, right? Maybe 3.5 hours. Okay. Now, introduction to hydrocarbons. Compounds containing, so basically there are two kinds of hydrocarbons that we'll see. One is saturated, one is unsaturated. Saturated means which has single bonds, okay. Unsaturated means which has double or triple bonds, that means which has multiple bonds, right. Single bonds, we know that single bonds are by alkenes, and unsaturated are which are having double and triple bonds, that is alkenes and alkynes. Okay, now let us see the saturated hydrocarbons, that is your alkenes. Now alkanes are open chain acyclic, they are not cyclic. Cyclic hydrocarbons are different, right. Hydrocarbons comprising homologous series. Homologous series means which is having the difference of CH2 group, that is called homologous series, right, with the general formula CnH2n plus 2, that is the general formula. They only have single bond and therefore are said to be saturated, right. Next is they are also called paraffins, right, they are also called paraffins because of low chemical activity. They are not very chemically reactive. That's why the chemical properties, you will see only 1-2 reactions which are important for you. Otherwise, you will not see a lot of reactions in alkanes, right. Then alkanes are also known as paraffins. Petroleum and natural gas are the main sources of the alkane, right. Now, next is isomerism. Now guys, for isomerism, let me tell you very clearly. For the isomerism of the alkanes, right, this we have already talked about. This is N-iso and neo. I have already talked about this thing, right. N means normal, iso and neo means branching. Okay, so firstly, the two or more compounds have same molecular formula but different carbon skeletons. These compounds are called chain isomers. If the parent chain is different, parent chain is different in this case. Can they show any other isomerism? No, they can only show branching. For example, you have butane that is like this. Okay, now it can have branching like this. That means they can only show different chain isomers, which one will not include any branching, other will include the branching, right? Now, the phenomena is termed as chain isomerism. So if they ask you what kind of isomerism is shown by alkenes, chain isomerism is the only isomerism shown by alkenes, right? Next is, as you can see here, what is iso, what is normal, what is neo. Okay, as I have already told you, N-butane means there is no branching at all. Now there is no branching here, there are 4 carbon atoms, so it is called N, means normal butane. What is isobutane? Here you should have a carbon which is linked to 2-methyl group. Then this particular group is called iso group, right? So here, as you can see, we can see this kind of group in this chain. That's why we can say this is iso. And how many total number of carbon it has? 4. So it is isobutane, right? Okay. What about this one? This is normal pentane, N-pentane. This is iso. Why? Because this carbon has 2 methyl groups linked to it, so it is called iso. Total carbons are 5, that is why it is isopentane, right? What about this one? Now neo means when 3 methyl groups are attached to the carbon. Okay, when 3 methyl groups are attached to the carbon, that is called neo. But one important point to remember, that neo will always start from pentane. Okay, so here it is 1, 2, 3, 4, 5. So it is neopentane. Neopentyl exists, neobutane does not exist. Okay, everybody, is that clear? Right? So that was about the simple naming iso-neo. Right? Next is preparation of alkanes. Right? Okay, yes, everybody. Next is preparation of alkanes. Yes, everybody. Next is preparation of alkanes. Conformers of alkanes, we will do that, but not here, right? We will do the conformers of alkanes in isomerism, okay? When we will do the questions of isomerism, we will do conformers of alkane with that only, right? Okay, so now let us see the preparation of alkanes. Now, let us see preparation of alkanes from unsaturated hydrocarbons, from double bond, triple bonds, how to prepare, from alkyl halides, from carboxylic acids, right? So let us come to the first thing, that is from unsaturated hydrocarbons. See, if you have double bond, now from this particular section, I'll tell you different types of reactions that they can ask you in JEE exam, right? So first is simple hydrogenation. See, very clear thing here. If you have a double bond, okay, if you have a double bond, obviously when you will add hydrogen into it, then this pi bond, now always remember that in the multiple bond, if you talk about double bond and if you talk about the triple bond, okay, in this case, the first bond that is formed is sigma bond. The other bonds are pi bonds. So here one sigma, other two are pi bonds. And pi bonds, because of the sideways overlapping, are loosely bound to each other. That is the reason pi bonds we can easily break. Now, when we are adding hydrogen, the sigma bond will stay intact, but the pi bond will break, and we will have the attachment of 2 hydrogens here. Similarly, here, if you add 2 H2 molecules, right, 2 pi bonds will break, and you will have the formation of alkane here. 2 extra hydrogens will get attached here. Here we know that 2 bonds are already there. So let's make 2 bonds here. 1 bond is already there. Let's make 1 bond here. Right? So this is how, with the help of hydrogenation, we can have the preparation of alkanes. But here we have some twist. Okay, so I'm going to tell you about the twist. Right? Okay, everybody. First is how it is done. What are the reagents that we can use? So first kind of hydrogenation is the catalytic hydrogenation, which has catalyst, that is from your D block, transition block. Now these catalysts are added into it. That is, ma'am, simple, okay, catalytic hydrogenation. But in your exam, what kind of questions they can ask you is not related to that it is catalytic hydrogenation or not. They will ask you question like what kind of addition this is. So this is a syn addition. Now this kind of questions are asked. That means if you have a double bond here, for example, you have CH2, you have CH2, you are adding deuterium, D2 here, right? D2 in the presence of, let's say, nickel, PD or PT, whatever you are adding, right? Now, which is the correct answer? Now, I'll give you two answers here. You'll tell me which is the correct answer, right? These are the questions out of your JEE only, right? CH2, right? Let's write it like this. C, this is C, H, right? H, H, right? This is D, this is H, this is H, this is H, and this is D. Or C, C, this is, okay, you can make this like this also. You can make it like this also. You can make it like this also, right? In the syn addition, if I say deuterium and deuterium on same side, these are on same side, right? This is hydrogen, this is hydrogen. This is hydrogen, this is hydrogen. Deuterium and deuterium are on opposite side. This is hydrogen, this is hydrogen, right? If this is given to you, right? If this is given, if I want to make the question even more interesting, then what I will do, if I want to make the question even more interesting, then what I will do, instead of this simple CH2, I'll just write here, this is your CH3, this is H, this is H, this is CH3. Now you need to tell me what is the correct answer. Now you need to tell me what is the correct answer here. Everybody, first or second, this is your A and this is B. Which one can be your correct answer? Everybody. I told you one thing, right, in the previous lecture. How many marks is required to get qualified in advance in general category, right? Okay. Madan, firstly, so you study here, right? Then I'll tell you. Okay. Now, tell me one thing here. Focus on the lecture, what I am teaching, instead of asking unnecessarily questions here. Okay. So, otherwise, I'll make a question answer like quiz for you, or I'll do one live session where we will ask general questions, right? But here, focus on this kind of thing, right? What you are here for, right? Now, tell me one thing. This is your, if you talk about this one, this is trans alkene, which is negative, and this is your syn addition, which is positive. So positive and negative will give rise to a negative. That means opposite will be formed, where D and D are attached on the opposite positions. So B is the correct answer. A is not the correct answer. Okay, A is not the correct answer. B is the correct answer. Okay, understood? Now, if they give you the same question, but now they are giving you, instead of trans, they are giving you cis. Okay, instead of trans, they are giving you cis. Instead of trans, they are giving you cis. Cis means CH3 here, H here. Now, this is your cis. This is cis. Now, as I told you, cis means positive, right? Cis means on the same side. That means it is positive, right? This is also positive. Positive multiplied by positive is going to give us positive or negative. Obviously, positive multiplied by positive will be positive only. So, positive means on the same side. Positive always means, see, those students who have not seen my past lecture, right? For those students, like, let me be very clear, cis is on the same side positive. Syn addition from the same side, it is also positive, right? Erythro or Therio is on the same side, erythro is on the same side, Therio is on the opposite side. Same side means like this, opposite means like this. Okay. Now, whenever positive will be multiplied, answer will be positive. Positive negative means answer will be negative. Negative positive means answer will be negative. Negative negative means answer will be positive. Right? So here positive will give rise to positive. That means on the same side. So this is the correct answer. This is the wrong answer. These kind of question they will ask you in JEE. Not general simple question, what is catalytic hydrogenation? Guys, this is not your board exam, right? So they will ask you these kind of questions. Everybody in the chat box, let me know, is this thing clear to you? Is this thing clear to you? How on changing the alkene, the result is changing, right? Okay. Is this thing clear to everybody or not? Is this thing clear to everybody or not? Right? So that was the first thing about this reaction, that it is having a syn addition. Second thing is that it is having no intermediate. No intermediate. No intermediate means it is a surface reaction. It is a surface reaction that happens by adsorption. So basically, on the surface of the catalyst, this is the surface of the catalyst. On this surface, right, the reaction will happen, right? So there is no intermediate that is formed here. There is no carbocation, carbonyl, free radical, nothing is formed here. It is a surface mechanism, right? Okay. Now, second thing is four-membered transition state is formed. Four-membered transition state is formed. Transition state is formed. How can we say it is a four-member transition state? For example, this is the surface, right? This is your alkene. For example, here you have alkene. This is CH2 double bond CH2, right? Here you have hydrogen. So what will happen? This bond will break, this bond will break, and this bond will break, right? This bond will break, this bond will break, and you will have the formation of a new bond, that is this. And this is that four-member transition state. Okay, this is that four-member transition state that is getting formed in this reaction. Okay, this is that four-member transition state. Last is, it is an exothermic reaction. It is an exothermic reaction. Heat is released in this reaction. Okay, got it? So these kind of questions. Next is, let us do Sabatier-Sanderson's reaction. Let us do Sabatier-Sanderson's reaction. Okay, I think Sabatier-Sanderson's is already, I have mentioned it somewhere, right? I think it will be, okay, that is not mentioned here, so no worries. I'll just write it here. Sabatier-Sanderson's reaction. Basically, it's the same thing only, right? From nickel, by taking nickel as a catalyst, right? With this double bond, we have, suppose we have a double bond, we have a triple bond, right? We have a triple bond. When we are adding hydrogen at 200 degrees Celsius, right? Here we are adding hydrogen at elevated temperature. So basically in Sabatier-Sanderson reaction, the temperature, the catalyst is fixed, that is nickel, right? Nickel you will use here, right? And the temperature is elevated, 200 to 300 degrees Celsius will be the temperature, and you will get the alkene here, and you will get the alkane here. Okay, and you will get the alkane here. Yes, everyone, is that clear? Yes. Now with platinum, if you use, very important point, if you use platinum or palladium in this place, PT or PD, in that case, it will happen at a normal temperature. But when you are using nickel, the temperature will be elevated, right? Okay. Hello. Okay, the temperature is going to be elevated here, right? Okay. Now, the next question that can be asked from here, as you can see, these are the simple reactions. These simple reactions, they are not going to ask you. Like, what is this double bond? Like, definitely this so anyone can answer, right? But what kind of question they will ask you is I'll just draw one diagram here. Right? They can ask you these kind of questions, right? These kind of questions they will ask you, that here you have added 1 mole of, or you can say 1 unit of 1 H2, 1 unit of H2. right? Or you can say 1 mole of H2. Then what will be the answer? Which is more preferred? Now you have 4 multiple bonds. 2 are the alkynes, 2 are in the double bond, 2 are in the triple bond. Now, which pi bond you will break? That is the question. This can be asked to you. For that, you need to remember that alkyne has more like preferability as compared to alkene. So, alkyne will be, and if it has just 1 mole, then it will break alkyne, right? Not alkene. So, this pi bond will break, right? And hence the answer will be, hence what is going to be the answer? If this pi bond will break, what is going to be the answer? It's like this. This pi bond will stay as it is. This pi bond will stay as it is. This one pi bond will break. And hence you will have this as the correct answer. This is going to be the correct answer that you will have. Okay. Now if they are saying that you have 4 moles of H2, then definitely break all the pi bonds. This one, this one, this one, this one. Then the answer will be very simple. All pi bonds will get break. Right? Okay. Yes, everybody. Yes, everybody. Is that clear? Yes. Now, is that clear to everybody? That 1 mole, if 1 mole, then we have alkyne has more, like we will prefer alkyne over alkene. Okay, always and always. Right? If we have the choice, in these hydrogenation reactions. Next kind of question that they can ask you is transfer, or you can say internal hydrogenation. Transfer hydrogenation. Anybody in the chat box, what is transfer hydrogenation? What is transfer hydrogenation? See, transfer hydrogenation is basically when you don't take H2 from outside. You take it from here only. So, I'll just make one bond here. This is CH2, double bond, plus here you have this molecule. Now, what is going to happen? What is going to happen? Firstly, how many of you remember aromatic, non-aromatic, all of these things? How many of you remember this? How many of you remember this? Yes, everybody. How many of you remember that this is aromatic or this is anti-aromatic? Let me see in the comment section. How many of you can answer this? Okay, let me see in the comment section. Everybody, let me see in the comment section how many of you can answer this. Now, as you can see here, definitely it is a non-aromatic compound. No, it's a non-aromatic compound. Its PCC is not yet completed. It's definitely not planar. Complete conjugation is not present here. It should be a complete conjugation, right? Okay, so this is non-aromatic compound. This is non-aromatic compound. Because it is a non-aromatic compound, we know that aromatic is more stable as compared to non-aromatic. And here we know that it has 2 more hydrogens here, 2 more hydrogens here. So what will happen? It will eliminate 2 hydrogens from this side. This hydrogen and this hydrogen will be eliminated, right? And what will happen? A pi bond will shift here, right? And what you will have the formation of aromatic ring here. That is 2 bonds will stay intact, and from this elimination, this bond will shift here, and hence you will have the formation of this pi bond here after the elimination of this H2. But this H2 will be added to this place, and hence you will have the formation of CH3 and CH3 here. Now, why this happened? Because a non-aromatic compound wanted to become aromatic in nature, And second thing is, once it has two hydrogens, it will try to give these hydrogens to this pi bond so that it can also become alkane. Okay, yes, okay, understood? Yes, everybody? Yes, everybody? Okay. Now, next is one more kind of addition, that is on 1,4 position. Okay, let us see the addition on 1 and 4 position. Right, just give me a second. Let me take one example of that. Yes. Let us take one example of 1,4 addition. 1,4 addition. 1,4 addition. 1,4 addition. Acha, tell me how many of you are interested in studying from me? How many of you are interested? Let me see in the comment section. Right? Because as I can see in the chat, you actually guys, you feel like that the teacher is here, teacher has no content to teach, teacher has come here totally blank, and you just ma'am please teach this, ma'am teach this. Can't you see what is the mention in the like title? Alkanes and alkenes, full theory will be taught here. So instead of saying this again, this and that, ma'am please, new and projection, ma'am, what are they, ma'am, this and that, guys, I'll teach you everything. Okay, I'll teach you everything. Right, what I have thought that I'll teach you today, let me complete that first. Right, okay, after that you have the comment section. You can obviously write down that what you want me to teach. Right, what are your questions? You can definitely write down in the comment section and tell me that ma'am, I am weak in this topic, please teach me this topic. That I'll definitely teach you. Right, maybe through questions, through previous year questions as well. But see, don't disturb the class like that. And those students who actually want to study, I want to see that in the chat box, because otherwise, see, otherwise I will feel I will lose the motivation to teach on this channel, right? Because when the effort should be from two sides, right? One side love is always heartbreaking, right? So I don't want to have a one side love with you guys, because I am only giving, like I am only here preparing notes, collecting the previous year questions for you guys, right? Making the best notes for you, so that nothing I can skip on this lecture. But what in return you guys are giving me, right? Respond. That is what I expect. If you can't give me that, then it's from the next week you will not see my lectures on this channel. Okay, so I want to know your honest feedback. If you want to study from me, if you don't want to study, you can obviously say that ma'am, we are not able to understand whatever you are teaching, so that's why we don't want to respond on this channel, right? So I'll just stop teaching on this channel. Okay, I'll request the team so that they can give you some other teacher, and I'll just not teach here, right? Okay, now it's totally your choice, what you want, what you want. Okay, otherwise wasting my energy coming here daily, wasting my energy is of no use. Okay, that's seriously of no use. Chalo, I can't see anything in the chat box. So guys, let's end the session today. Okay, let's end the session. There is no use of doing all these things. I'll end today's session, and I'll also delete the lecture of next Saturday. I think I was taking hydrocarbons. I can't come here daily and ask you that please respond. I am not a beggar here who, like, I am a teacher, right? You need to give me the respect of a teacher. If you can't, then I will not teach. Okay, so yes, I am very serious about that, and I'm not at all joking, right? I have paid batches also, right, that are continuing. I am teaching on NEET as well, right, and I'm teaching on JEE as well, right? There is a lot, right? So if you don't want to study, I am still giving my time here, right? I am not giving just 2 hours. I could have done the class in 1 hour and go, right? I could have just taught you the previous year questions and go. I am here teaching you everything, right? But still, if you have no regard for that, then I will not teach on this channel. That's, I'm very serious about it. 24 students sitting here laughing at this. Huh? Ma'am, only few days left for us. Then that's why I'm here, na? That's why I'll stand here for 4 or 5 hours and teach you. You can't even tell me if I'm clear to you or not. Is that of a big task to do? Very disappointed by you guys. Very disappointed. Very disappointed. Why I have to come here and scold you daily? Huh? There's so many students are saying that's why I'm teaching again. But trust me, if you guys will not respond, I will not teach. I'm not asking you to chit chat here with each other. What I am asking is, when I'm asking you, are you able to understand this or not? Say something. It takes just 1 second to type yes, ma'am. Right? You can type that. Right? If you can't do that, I'll drop my pen here and I will not teach. Right? Okay? So don't make me feel like I am teaching these walls. Okay. Now you just make me feel that, okay, should I put that much effort or not? Don't make me question myself. Okay? Better for you, better for me. I am not a very strict teacher who will just scold everyone here. Why you have made me like that? Because of this not responding, taking everything for granted. Right? Now, okay. So now 1,4 addition. Let us see 1,4 addition here. 1,4 addition is when you have, let's say you have 4 carbons here, double bond here, double bond here. Right? This is what you have. Now, what will happen in this case? Right? For example, you are adding 2 deuterium here. 2 deuterium, this is D2 you are adding here, only then you will be able to understand what is happening. Right? Now, this pi bond will shift here. This bond will shift here. This pi bond will shift here. That means, can I say that if I need to draw it again, this is C, this is C, this is C, this is C, and this is D2. This is D2. Now, can I say that this bond is actually breaking? This bond is breaking here. One more bond is breaking here. Right? Which bond is intact? This one bond is intact. This bond is intact. And which bond we are forming here? This bond we are forming here. This bond we are forming here. Right? This bond we are forming here. Right? Now, in the end, what will happen? All the blue dot 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 will just, it will be eliminated here. And what you will have in the end? This is C, this is C, this is C, this is C. And here you will have double bond in this side. You will have one single bond here, one single bond here. And the deuterium will be attached on this place, on this place. Right? So can I say that you have added, if I take this as 1, this as 2, this is 3, this is 4. So you have added hydrogen at 1 and 4th position. Right? So can I say that you have added hydrogen at 1 and 4th position? Right? Okay. Yes. Okay. So can I say that you have added 1 at 1st and 4th position? You have added? Stupid people. Seriously. Okay, so this is at 1st and 4th position. You have added the see, do you guys realize? Some mentally retarded person. Yeah. Wait a minute. Mentally retarded, psycho, needs psychiatrist help. Okay, guys, is that user hidden on your chat as well? Right? Okay. Okay. Now this is 1,4 addition. right? This is called 1,4 addition. Usually what we assume that 2 hydrogens can be add here, 2 hydrogens we can add here, and maybe it is 1,2 addition, but in reality it is 1,4 addition. So this kind of question can also be asked to you, right? Okay, this kind of question can also be asked to you. So now these were the questions that can be asked to you related to hydrogenation. First is transfer hydrogenation. Then there is 1,4 addition they can ask you. Then between alkene and alkyne, what you have to choose, this they can ask you. Rest, okay? Yes. Very good, Nancy. Nancy is also here, so I'm very happy about it. Yes. Now, second is from alkyl halides. What is alkyl halides? Alkyl halides is Rx. Now, from Rx, how you can prepare alkane? Alkyl halides, except fluoride, is reduced with zinc dilute HCl. This is your JEE mains question. Okay, this is your JEE mains. This was asked in the chain reaction, right? So zinc HCl, when you add, then we get respective alkane. That means if we have Rx and we add H2 in presence of zinc and some acid like HCl, you will get RH. Here you are getting CH4. Here you are getting C2H6. Here you are getting, replace this chlorine and add hydrogen. Here you are getting propane. So this question has been asked in JEE. Okay? Yes, very good. Okay? Yes, I'm so sorry. Yes, Mansi. I'm so sorry. I'm so sorry. Okay. Yes, Mansi. I totally it's a confusing thing for me. Right? Now, Ashwin, yes, sure, you can watch this video. Definitely you can watch, because this is also going to help NEET aspirants as well, right? But in the end, I'm going to teach some part you can skip here, which are complicated. Otherwise, you can watch the full lecture, right? From alkyl halides. Now, from alkyl halides, one more reaction is Wood's reaction. In Wood's reaction also, we will do a lot of questions here, right? In Wood's reaction, simply first is, what is a Wood's reaction? Here Rx in presence of sodium, and Rx is added here, and here what will happen? This Rx and one more Rx, X will be eliminated, like this thing will be eliminated, X, Na and X. That means it will be minus NaX, that will be eliminated, and these two will combine together to give us R. Right? Okay. Now some important things about Wood's reaction, right? Definitely this reaction is very, very important, and they can definitely easily ask you this question. Now first is, what they can ask you is, what kind of alkanes we can form out of this. So unsymmetrical alkanes we cannot form in Wood's reaction. Alkyl halides react with this in presence of dry ether, then we get higher alkane. It is used for the preparation of higher alkanes containing even number of carbon atoms. That means symmetrical alkanes can be formed here. Why unsymmetrical alkanes cannot be formed here? Let us take an example here. Why unsymmetrical alkanes we can't form here? So if you talk about normal alkanes, this is CH3, it will get double and you will get CH3, CH3, which is even number and symmetrical. This is C2H5, this will get double and you will get C2H5 bond C2H5, right? You will get double the amount of alkyl chain that you had in alkyl halide, right? Now, just imagine that you get CH4. Now, first limitation is CH4. Why CH4 cannot be prepared? To prepare CH4, this is only one carbon. So, if you add methyl halide and Na, definitely double the number of chain will be formed. So, it will form not methane, but it will form ethane. So that is the reason you cannot form CH4 here, right? By using Woods, because number of carbon atoms vary every time double in the production. So one is not a double of anything. In the same way, odd number of alkenes cannot be formed here, right? Next is, wait a minute. I'm just waiting for one more. Okay, chalo. Let's do this here. Oxygen and moisture should not be allowed. Now, Second is important thing is oxygen and moisture we cannot allow. No, sodium is a very explosive metal, right? So basically because of that, when it has oxygen or moisture, it will react with that, right? So oxygen should not be allowed in the reaction medium. Sodium is highly reactive and in open air, so it should be kept in kerosene. This you must have learned this line in lower classes, maybe 8th or 9th class, right? That sodium should be kept in kerosene oil. Reason being because sodium is very reactive in oxygen and moisture, so it will give you Na2 oxygen. That means sodium oxide will be formed instead of using it for the formation of alkane, right? That is why we use dry ether. That is why we use dry ether. We don't simply use ether. Dry why we use? Reason being because we don't want moisture in the reaction mixture. Why we use ether? Why we use ether? Because sodium, right, when it has sodium is Na positive, when it has ether, ether means ROR, ether means ROR, this, ether means ROR. Now we know that oxygen has lone pairs. Oxygen has two lone pairs. That means 4 electrons it will have. Now what will happen? Because of the lone pair and the positive charge here, it will give us the solvation energy. And because of this energy, it will be helpful for this reaction to occur. That is why ether is used, dry used because of moisture. Right? Okay. Next important thing is, as I told you, only symmetrical alkanes can be formed here. Reason, okay, let's say if you want to make propane, you're like, ma'am, I want to make propane here, that is CH3, CH2, CH3. Now I'll say you need two alkyl halides here. One alkyl halide is CH3Cl, other is CH3, CH3, CH2Cl. These two alkyl halides you can use. You're like, okay ma'am, this is so very simple, I can easily prepare. Now what will happen in the end, when these CH3Cl, it can also give off, in reacting with other methyl chloride, it will give us ethane, CH3CH3. This can also react with itself, so it can also give us butane, CH3CH2, CH2CH3, right? Now, there are also chances that they react with each other. Then we can get CH3, CH2, CH3. So, it's not like we can't prepare this, right? So, it's not like we can't prepare the propane here. Definitely, we can prepare the propane here. This is unsymmetrical, but we will have a mixture of products here. Because of these mixture of products, it is very difficult to separate them out. That's why we don't use this method for unsymmetrical or odd number of alkenes, right? Okay, this is what they have written. It is not easy to separate due to low difference in their boiling point. Last is this reaction proceed through very, very important free radical mechanism, right? And free radicals join itself due to their nature, right? This proceeds via a free radical mechanism. So now based on the mechanism, I will just write some questions here, right? Okay, let me just write some questions here. Good questions, right? Okay, sure. Let us write some questions. I'm going to use one blank slide here, right? Now, firstly, let us see what is the mechanism. What is the mechanism? As I told you, it will give us free radical mechanism. So, what will happen? You have Rx, right? What will happen? It will give you the formation of R and X. Free radical mechanism means homolytic cleavage will occur here. Two electrons, one will go to this side, one will go to this side. You will have R free radical, X free radical. Now, what will happen? Here, for example, there are two molecules, two free radicals and two X are formed. So, what will happen? Sodium will also, due to free radical, it will form sodium free radical. So, what will happen in the last part? these two free radicals of R, they will combine to give RR, right? And free radical of sodium and X will combine to give us NaX. If you have 2Na and 2X, you will have 2NaX, right? That will be the answer, right? That is how you will get this as the answer. Now, based on the mechanism, I'll give you some questions. Just remember that this happens via free radical mechanism, okay? Just remember that thing. Now, these kind of questions they can ask you. Just writing the questions here, right? Okay, guys. So, just give me a second. Okay, so I'm giving you some questions here. Okay, yes. The question is CH2, CH2, this is X. Okay, this is X. Chalo, let's do this question only, right? This is X and this is X. This is the first question. You have dry ether and sodium. Sodium and dry ether. This I will not write every time, right? So, this is the first question that you have. So, here as you can easily see, what you need to do, you just need to break this bond by homolytic cleavage. Break both the bonds, right, and see what you will get. This is CH2, this is CH2. Because you have you are breaking this bond here, right? Yes, I'll explain. Don't worry. Just wait for a second. That's what I'm explaining here, right? Now, this is CH2 single bond CH2. When you break this bond, there will be a free radical present here and there will be one more free radical present here, right? Okay. Now, two things can happen. Let's suppose if you have two things can happen, one is intermolecular, one is intramolecular, right? One is intermolecular, one is intramolecular. These two things can happen. Intermolecular means between two different molecules. That means you have CH2, CH2, free radical, free radical. You have CH2, CH2, free radical, free radical. Now these free radical will combine with each other and they will give you a butane. This is the intermolecular Woods reaction that can happen here, right? Okay. Second is intramolecular Woods reaction. Intramolecular Woods reaction is when in that molecule only, this is your free radical, this is your free radical, they will together combine and they will make a pi bond here. That means you will get CH2 double bond CH2. Now it depends on which is more stable. Okay, it depends on which is more stable. Now guys, understand one thing, whether we will prefer intermolecular or intramolecular. So we will prefer intramolecular always, but there are some cases in which we will prefer intermolecular, right? I'll tell you what are those cases, but firstly, always and always you will prefer in most of the cases, right? Generally, you can write generally, intramolecular is the major product, so intermolecular is minor product and intramolecular is the major product. That's why in the exam, if they ask you this in the exam, the correct answer will be this ethene will be formed, not cyclobutane. That is not formed in the majority, right? Okay, yes, intramolecular products are more stable as compared to intermolecular products, right? Now, one more question that will, give you one more clarity on this topic is this kind of product. CH2, CH2, CH2X, right? Now, what kind of free radical it can make? This bond will break, this bond will break. It will give you a free radical like this. CH2, CH2, CH2. This is free radical, this is free radical. As I told you, you need to see what is the intermolecular product, what is the intramolecular product. If you talk about the intramolecular product, that is when these two will combine together, they will make propane here, right? Because this will combine with this one, okay? This is your CH2, this is CH2, this is CH2, this is a free radical, this is a free radical. they will combine together and give you propane. Okay, that's why what I am writing here directly, propane it will give you, cyclopropane. If this is intermolecular, we know it will be CH2, 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 CH2. Now students usually get confused here, right? Okay, students usually get confused here. They think that, ma'am, in intermolecular you have 6-membered ring. Ma'am, here you have 3-membered ring. So, ma'am, this must be more stable, because we know that according to the according to the angle strain, 6-membered ring is more stable. But as I told you, you will not check the stability unless and until you have some anti-aromatic compound, because anti-aromatic compounds are least stable compounds. So if you don't have any anti-aromatic compounds, directly the answer will be intramolecular will be the major product. Intramolecular will be the major product. Okay. Yes, everyone. Yes. Now, let us see one question. Let us see one question which is going to expand more horizons for this topic, that is Br and Br. Again, because of free radical formation, what you will have here? You will have this kind of product. This is dot, because 2 bonds will break here. 2 bonds will break here. Now see, 2 things can happen. Okay, 2 things can happen. This is intermolecular. This is intramolecular. Intramolecular. Now, very simple thing. If intramolecular product is formed, we know that these 2 will combine together and it will give us this kind of product. Now, it is planar, definitely it is cyclic, it is complete conjugation, PCC is followed, right? Second question is, how many electron? It has 4n pi electrons. That means it is anti-aromatic. So whenever you have anti-aromatic compound, nobody wants to give anti-aromatic product. So the reaction will not proceed through this. Instead, it will give you intermolecular product. That is, this kind of product will be formed. Now, in this case, this is the major product and this is the minor product and this is the minor product. Okay, this is the major product and this is the minor product. Reason is because here anti-aromatic compound is formed, right? Okay, very good. Non-aromatic compound it can still prefer, because non-aromatic compound is more stable as compared to anti-aromatic compound. Okay, yes everyone. Okay, now let us see the next question. Let us see the next part, that is preparation from carboxylic acids. So if you talk about the next preparation, that is from, we have done from alkyl halides, right? Now let us do the preparation from carboxylic acids, right? Okay. Achha, in alkyl halides we also have 2 more reactions. We can do that as well. This I have taught you in haloalkanes, haloarenes as well. If you remember, we have also done 2 more reactions, that is Franklin and Core-House synthesis. Do you remember that we have done those 2 reactions in haloalkanes, haloarenes? That was the last chapter. Okay, so in this you can also add those 2 reactions. Franklin reaction which used zinc, right, instead of sodium, and Core-House synthesis we used Gilman's reagent, that is in copper and lithium. Okay, CuLi. Okay. Now next is preparation from carboxylic acid. So this is a very important reaction, that is decarboxylation reaction, and this also is one of the favorite topics. This question is usually been asked. R2CuLi, Culi, right? Okay. So Gilman's reagent is used in Core-House synthesis, and important thing I told you in previous lecture as well, that in Core-House synthesis, in Franklin, in Wood's reaction, Wood's fatigue, we have done those reactions before as well, right? Now, in all these cases, you can't make unsymmetrical alkenes. But in Corey house synthesis, you can make unsymmetrical alkenes. That is the most important part about Corey house synthesis. Okay? So you can note down that. Now, let's come to decarboxylation reactions. Decarboxylation reactions means to get carbon dioxide out of that, right? So basically, if you have RCOOH, this will give us the formation of RH. That is called soda-lime decarboxylation. Soda-lime decarboxylation means when you use NaOH, that is caustic soda, and quicklime, it will give a soda-lime decarboxylation reaction, right? Sodium salt of carboxylic acid on heating with soda-lime give alkenes. Soda-lime is a mixture of this. In this reaction, always form one carbon atom less than alkane, right? That means if you have RCOONA, you will have the formation of one carbon less alkene. That is RH will be formed. Very important thing. Elimination of CO2 from carboxylic acid is called decarboxylation because we have taken out CO2 from that, right? Now, let us see this. This is RCONA plus NaOH. This is soda lime. We will heat it and we will get RH. For example, you have CH3CONA. This will be eliminated. That means this CO, this will be eliminated, right? This is acting as a catalyst. Okay. CO is acting as a catalyst. So, here Na2CO3 will be eliminated, right? Okay. And you will get the alkane, right? Okay, okay, everybody. Now let us do some questions based on this. Let us do some questions based on this. Let us do some questions based on this. Okay, so now these are the questions. I'm just writing these here, right? Just give me a second. Yes, the question is, first, the topic is what is the mechanism here? Firstly, though, you need to know the mechanism. Only then you will be able to answer the questions here. Okay? Firstly, you need to know the mechanisms. The mechanism of this reaction is, the mechanism of this reaction is you have RCOO negative. Right? It will be something like this, RC double bond OO negative. Now this bond will shift here, this bond will shift here, and this bond will shift here, and you will get R negative plus CO2. That is how carbon dioxide is eliminated. Now this R negative, you add H positive, we will get the formation of RH. Right? Okay. Okay. So now the important thing to note down here, that the intermediate, I told you that in all the reactions you need to know the intermediates. Only then you will be able to answer good amount of questions from that. Right? Yes. Intermediate is carbanion. Okay. Intermediate is carbanion. Right? Okay. So now let us see what kind of questions they can ask you based on this. First question they can ask you is rate of reaction. Rate of reaction. Now you need to tell us that which will give us maximum rate of decarboxylation reaction. Okay. So the question is, in the rate of reaction, the question is, this is CCl, COOH. This is CH3, CH3. CH3, CH3. This is A part. B is when you have CCH3. This is H, this is CH3, COH. Now, this is basically usually in JEE Advanced, right? They try to ask you question in relation of, even in JEE Mains, right? They try to ask question that have the relation of both GOC or maybe 2-3 chapters are combined, maybe GOC is combined in some reaction. Okay, so this is one of those questions. So here it is CCH3, CH3 and CH3 here, and this is COOH. Now you need to answer this. See, it is going to form carbanion. Now always remember, carbanion is like money, right? No, it's like stress, not like money, it's like stress. Now, if something is already negative, you are donating the electrons, you are giving more stress to them, so they will become unstable. If someone is already under stress, you are taking out the stress from them, so they will become stable. That means we don't need electron donating group, we need electron withdrawing group here, right? This is what we need. So here we know that everything is same. The only difference that we can observe here is this Cl here, this hydrogen here, this CH3 here. Everything else is same. Now we know that Cl is having a minus effect, CH3 is having plus effect. Halogen is having two kinds of effect. What is that? It is having minus and plus M. We know that minus effect is more dominant. See, one more important concept they have asked you in this question, right? That Cl is having minus I effect, which is more dominating, right? It is a deactivating, though it is showing plus M, still it is a deactivating group. So that's why it is taking out the electron. We needed someone who can take out the electrons here and make the carbanion, this carbanion here, this carbanion here, right, this carbanion here more stable. So answer will be C is the most stable, then you have B, then you have, wait a minute, not C, A is the most stable, then you have B, then you have C. This will become your final answer. Okay, this will become your final answer. Okay. Okay, shall I give you one more question here? Okay, one more question here related to this. Okay, let's try to solve this. The question is, you have COONA, this is CH3 and this is CH3. This is also CH3. Now, here it is CONA only. CONA only. Now you need to tell me which is more, like which is in which the rate of reaction is more. Now here this kind of reactant anion will be formed. It is giving it electron. There is no one to give electrons. So when someone is already under stress, you are giving them more stress, more electron donation, they will become unstable. That is why here B has more rate of reaction as compared to A. More stable is the carbanion, more will be the rate of reaction. Okay? Okay guys? Yes everybody? Now, some of the questions I am going to write here. You need to answer me on decarboxylation, what will be the answer? Okay, you need to answer me on decarboxylation, what will be the answer? A part, B part, and this is C. Okay, you need to answer this. Right, what will be the answer here? So first is CH3, C, COONA, and this is H. Which thing will be formed here? What will be formed here? Everybody, what will be formed here? One more question is, you have COONA and this is CHO, right? What will be formed here, right? Then if you have COONA here and COONA here, then what thing will be formed? Or you can also say H. Then which thing will be formed? then D is, chalo, I think that is enough. Okay. Now let us see how many of you can answer this. How many of you can answer this? Simple, guys. These kind of questions are asked, okay? Based on hindrance. Can we say answer based on hindrance? No, no, no. Not on hindrance. Maybe some question, right, which has a lot of hindrance, right? But in this case, no. Why? Because in the mechanism, there is nothing that is attacking here. There is this little chotu sa, very small H positive, right? It is going to combine with this one. So there is nothing related to hindrance. R negative you have, right? Okay. Understood? Yes. Now, here as you can see, just eliminate CO2 from this side, eliminate CO2 from this side, add HH there, you will have CH3, CH3. Ethane will be formed in this case, right? Okay. In this case, not isobutane. Array. RCOONA, this thing will be eliminated. Replace this thing with H. So replace this CONA with H, replace this CONA with H, you will have CH3, CH3, right? Okay. What about this one? What about this one? Again, do the same thing. Replace this COONA with H, and what you will get here? This is benzene. No, definitely nothing will happen to this CHO, it will stay as it is, and replace this with hydrogen, and we don't write hydrogen on any benzene ring, so that's why it will be this one, right? Here also replace this CONA. See, COH will automatically, in the presence of NaOH, it will get converted to Na. So even if they have given you COH, that means you will convert it into CONA, right? Now these two will be replaced, and what you will have in the end? You will have the formation of this and hydrogen here, hydrogen here. And on benzene, we don't write the hydrogen, so directly we will say benzene is formed in this case, right? Benzene is formed in this case. Very good. Okay, not benzoic acid. This is benzaldehyde. This is simply benzene is formed. Okay. Yes, this is benzaldehyde is formed. Here simply benzene is formed. Okay. Understood, guys? Everybody? Any problem here? Any problem here? Okay. So there is one more question, right? Firstly, let us do Kolbe's electrolysis. After that, we will do that question. Okay. So Kolbe's electrolysis is basically a free radical mechanism. So the questions will be somewhat same as Wood's reaction only, right? Okay. So it will be somewhat similar. So Kolbe's electrolysis method, this is first you need to understand this is a free radical mechanism. Alkanes can be prepared by electrolysis of concentrated solution of sodium potassium salt of this. First you will see the mechanism also. There are 2-3 questions that can be asked from this. Methane cannot be prepared by this. Why? If you have RCOONA, on eliminating this thing, you will have, you will just double this ring here, double this chain here. This will be R. So, on eliminating carbon dioxide from here, double the chain, double the alkyl chain of that carboxylic acid. That will be your answer. Okay? Not RH, it's RR is the answer. Right? Alkenes can be prepared by electrolysis of concentrated solution of sodium potassium salt of carboxylic acid. Right? Now, that's why alkene cannot be prepared from here. Now, let us see the mechanism. Mechanism is very, very important. I'll tell you from mechanisms what they can ask you. Right? Okay? Let us see from mechanism what they can ask you. See, firstly, what will happen? This in the presence of water and electrolysis, it will give us alkane, then carbon dioxide, then water, then NaOH. Now, how this thing is formed? Okay, let us see that. So, at anode, first step is this CH3CONA. will be distributed, dissociated into the ions. This is CH3CO, this is Na, right? These are the ions. At anode, we know that there is oxidation. There is loss of electron. At anode, there is loss of electron. So basically, this is the electron. 2 electron it will lose, right? So these electron it will lose from this oxygen side only, right? When it will lose 2 electrons, it will be left with 2 electrons here, and hence this thing will be formed, right? Okay, electrons it is going to lose. So I'll give you a more better explanation of this. Just give me a second. Basically, what will happen here? You will have two molecules. You will have two molecules of CH3COO. What will happen here? See this. This electron, first electron will jump here. One electron it will lose, right? So what will happen here? Each molecule will have CH3, C double bond O, O and this free radical. We have two molecules. From two molecules, 2 electrons will be lost. Okay? Okay? If you don't want to consider 2 molecules also, leave this. Just don't consider 2 electrons also. Don't consider 2 electrons also. Right? Just remember that you will have CH3COO negative, right? Electrons will jump here and you will have the, because you need to lose the electrons at anode. So it will, 1 electron will go here, 1 electron will be lost, and you will have the formation of this kind of anion, right? Now what will happen here? 1 electron from this thing, what will happen? 1 electron will jump here and 1 electron will jump on this carbon. So this carbon will be C double bond O, O, this is one free radical, one free radical. They will make a bond and there will be a double bond here. That means it will lead to the formation of carbon dioxide here, right? It will lead to the formation of carbon dioxide. Carbon dioxide will be formed here. CH3 free radical is present here, and hence what will happen? This CH3 free radicals, when we double of the CH3 free radicals, we have free radicals, right? So this CH3 free radical, firstly to at anode 2 things are formed, right? First is CO2 is formed, other is this CH3 will combine together to form ethane. This thing is formed. Now at cathode what will happen? At cathode we know that in electrolysis definitely we have water also, right? So in this water at cathode we know that there is gain of electron. So it will gain the electron, right? And what it will become? And what it will become? This is basically your H2O, right? This is basically your H2O. It will gain the electron like this, okay? 2 electrons, firstly free radical mechanism, there will be OH free radical, H free radical. They will gain the electron and this will become OH negative here after gaining 1 electron. So this will be OH negative and this is H free radical. H free radical will combine with one more H free radical. It will produce H2 here, right? And this OH negative with this Na positive, that will combine and give NaOH. So this is the total mechanism that will happen. What they can ask you? They can ask you at anode which thing will be formed, at cathode what is formed. At anode alkane and carbon dioxide, at cathode hydrogen gas, and what is the medium? Medium is basic, right? Okay, okay guys. So now one question from this one. One question I am writing from this one. Let's suppose you have CH2, COONA and COONA. What will be the answer? It is same as Wood's reaction. Answer is same as Wood's reaction. Make the free radical, right? Definitely, if on one molecule you have 2 free radical, intramolecular will be the major product. So answer will be alkene is the major product. Alkene is the major product here, right? Okay. So now this is your Wood's reaction. Now, if you talk about the alkane, okay, So now in this case also, yes, in this case also alkene is formed, right? Reason being because of the intramolecular thing. Whenever you have a free radical, then it will prefer intramolecular rather than intermolecular, right? Okay. So if you have a simple structure, if they are asking you a simple question here, they are asking you have a benzene ring or whatever, this is COONA, this is CH3. Now what will be the answer? The answer will be the free radical that is formed. The free radical that is formed is something like this. Okay. Firstly, let us make the free radical here. Minor product is butane. This is the minor product. This is the minor product. This is the major. Major is always intra. Intra is always the major product. Okay. Intra is always the major product. Now, here we have free radical that we can form here is, this free radical. Double the free radical should be the answer. So, this is the free radical, right? It will combine with this one more thing. It will be CH3 here and it will be CH3 here. That will be the answer that you will get here, right? Okay. Sodium formulate on Kolbe's reaction product. Why sodium formate, Nihar? Why sodium formate? Okay, sodium formate, you are asking me what will be the answer for sodium formate. Okay. Sodium formate is basically HCO. Nothing will happen here. Nothing will happen, right? Nothing will happen here, right? Because if you see the mechanism, the carbon dioxide will be lost. You'll be left with hydrogen only, right? Nothing will happen, Nihar. No alkane will be formed. Okay, good question. No alkane will be formed. Okay, yes. Now, next is one more thing can happen, one more question. Okay, I'll write it here. One more thing can happen. One more thing is disproportionation reaction. This can be applied to Wood's reaction also and applied to Wood's or Kolbe's. This can be applied to both reactions. I am taking the example of Wood's reaction, right? So I am taking this example that you have CH3, CH2X, right? We know that what is the free radical that can be formed here. The free radical that can be formed is CH3, CH2 free radical. है ना? So this is your reactant. Free radical you have to make here. Now the question is, ma'am, what is disproportionation? So see what can happen. Two things can happen here. Two things can happen. I'll just write it here also. Right? Okay. Why wouldn't free radical migrate in that second one, ma'am? Where free radical will not migrate? Where you are talking about, students? Where you are saying it will not migrate? Where you are saying that it will not migrate or what? It will stay here only. Okay? No rearrangement will occur. That is in case of carbocation. Okay? Okay. Now see what can happen here. This is CH. Basically this is CH2 and this is one hydrogen here. So what can happen? Even this bond can break here and this can give rise to, this is a possibility. This is a possibility. This can give rise to CH2 free radical, CH2 free radical, CH2 free radical, plus H free radical, plus here what we have, one more molecule is that this thing can happen, or we have this molecule. See, in a beaker, you have infinite number of molecules, right? So one molecule is staying as it is. One molecule is as it is, that is CH3, CH2, free radical. So in this beaker, now you have three kind of free radicals, right? Now what can happen here? This free radical can combine with this one. It can give you the formation of alkane. Plus this free radical can do intramolecular interaction, and this will give rise to CH2, CH2. So this is basically disproportionation, where even you can have the formation of ethene as well. Okay? Okay guys? Okay, everybody clear or not? Ethane will release one H and hence disproportionation. Yes, ethane will release one more H and it will give rise to the disproportionation reaction. Right? Okay. Understood? Now there is one more question that can be asked on the basis of this alkyl halide. Right? That is, we were talking about the reductions, right? Okay. So let us do one more reduction that can be asked to you. Right, reduction of alkyl halides, which can be asked to you, where we have done the reduction. I think here we have done the reduction, right? Before woods we have done the reduction. This was the reduction, है ना? So I'll just write it here also, here only. The answer can be zinc HCl, zinc H2SO4, or you can also use zinc CH3COH, right? You can also use zinc CH3COH. They can also give you zinc copper couple in ethanol, copper couple in ethanol, right? These things they can give you, okay? Right? They can also give you 1, 2, 3, 4. They can also give you zinc, then they can give you aluminium amalgam. So let's talk about red phosphorus. Red phosphorus plus HI. Just remember, this is a good reducing agent, right? It can even reduce like carboxylic acids, right? These things into alkenes. So this is important, right? It can even reduce the carboxylic acid and alkenes, right? Okay, so this is important. Now, other reducing agents. Do you remember other reducing agents? Do you remember other reducing agents? Everybody? Okay. One reducing agent is LiAlH4. What is the name? NaBH4. What is the name? pH thrice SNH. What is the name? Lithium aluminium hydride, sodium borohydride, triphenyl tin hydride, right? So here I'll draw just 2-3 things that what it is going to give us with 1 degree, 2 degree, 3 degree, right? Because this question also can be asked, right? So this is 1 degree, this is with 2 degree, this is with 3 degree, right? Okay, so I'm just going to draw a table here, right? I'm going to draw a table here like this, okay? So from this table also the question can be asked. I'll tell you from where the question can be asked. So this is, here nothing will happen and here it will give you alkene. Okay. With 1 degree alkyl chloride, this will give you, others are alkane only. Alkane, 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 alkane. Others they will not ask you. They will ask you question from here. They will ask you question from 3 degree alkyl halide. Okay. So they will ask you question from 3 degree alkyl halides. So I'll just mark one question here. What they can ask you. They can ask you that you have CH3, C, Cl, CH3, Cl, CH3. Now this is a 3 degree alkyl halide, right? If you remember, this is a 3 degree alkyl halide. because halogen is connected to that carbon which is further connected to 3 other carbons, right? Now, this 3-degree alkyl halide, when if we add, let's say LiAlH4, answer will be different. If we add NaBH4, answer will be different. With LiAlH4, it is going to give you alkenes. That means it is going to give you this carbon, this Cl will be eliminated. From here, this is your H2, this is H, this will be eliminated, this bond will shift here, and hence you will have the formation of CH3, CH3, double bond CH2. Alkene will be formed in case of LiAlH4. But in case of NaBH4, alkene will not be formed, right? Okay, yes, that is red phosphorus. Okay, in this case, this will not be formed and hence you will have the formation of, what is this called? What is this called? Isobutane. Isobutane will be formed here, right? Okay, isobutane will be formed here. Okay, guys, right? Understood? Everybody understood or not? So we have completed the preparation of alkenes. Okay, now let us do the properties. Let us do the properties of alkene. Everyone in the chat box, let us do the properties. I think so we have completed everything. Okay, there are some reactions that we are left with. Just give me a second. 2-3 reactions we are left with. Okay, 2-3 reactions we are left with. So I'm going to write those reactions. Next is from carbonyl compounds, carboxylic acids. This very simple thing, just write down that when we use red phosphorus in presence of HI, see, whenever we react something with HI, it is giving a reverse, it is giving us a reverse process, right? Because, you know, that's why what will happen, we have to add red phosphorus here, right? Okay, so it is going to convert all the things into alkenes, whether it's carboxylic acid, it's ketone, it's aldehyde, right? All the things will be converted, right? So whether it's your alcohol, okay, I'll just write it here, whether it's alcohol, whether it's ketone, whether it's aldehyde, whether it's carboxylic acid, all will be converted into alkene. All will be converted into alkane with the use of red phosphorus HI. Right? Okay? Okay? And now tell me whether same number, whether this carbon will be decreased or not? No. Same number of carbon. Same number of carbon. For example, you have CH3COOH. On using red phosphorus HI, same number of carbon means 2 carbons. So it will give you 2 carbon number alkene. That is, ethane will be formed here. Okay? Yes. Okay, guys. Understood? Same number of carbon we will have. Right, everyone? Now, I'm just going to write down the names here, right? Firstly, tell me from carbonyls. Do you remember from aldehyde or ketones, those 2 reactions? Clemmensen and Wolff-Kishner reduction. In Clemmensen, what you had? C double bond O, this is R dash. This was converted in the presence of zinc amalgam, right? In presence of HCl, this was converted to, this double bond O was converted to H2, right? When you had the same thing, but this is in presence of hydrazine, in presence of ethylene glycol, KOH, that means in the basic condition, it is converted to the alkene, This is called Clemenson. This is called Clemenson. This is called Wolff-Kishner. This is called Wolff-Kishner reduction. Okay? Yes. Okay, guys. Done. Done, everybody. Everyone in the chat box. Everyone in the chat box. Shall we move towards the properties here? Shall we move towards the properties? Acha, do you remember that even in Grignard reagent, one more reaction I recall, that even with Grignard reagent, for example, whenever Grignard reagent in the water, for example, you have alkyl halide, that is Rx, with Mg and dry ether, you will have the formation of RMgX, that is the Grignard reagent. Now, this in presence of water or any proton donating site, any proton donor, it will give you RH. It will give you RH. Water is a proton donor. Alkyne is a proton donor. So NH3, that is not a proton donor, right? So all the compounds which are donating the protons, right, that are Lewis acids, right? Because not all the Lewis acids, but yes, those Lewis acids which can donate proton, right, they will be with this Grignard reagent, especially with water, with moisture, it will give you the alkene, right? Okay. Yes, everyone. Now, let us see the physical properties here. Let us see the physical properties. So, in the physical properties, 1 to 4, it is a gaseous state. 5 to 17, it is liquid except for neopentane. Right? Exception is important. 18 and above, it is a solid like wax. Right? Alkanes are lighter than water, so it floats over the water. Alkanes are lighter than water. They are not heavy. That's why they will float. Right? That's why oil will float over the water. Whenever you put oil drops in water, they start floating on the water. Right? Okay. Color and odor. So basically, they are mostly colorless and odorless. The next 13 from pentene to heptadecane are colorless and odorless liquids. The rest of the higher alkanes are colorless solids at ordinary temperature. Solubility. Now see, alkane, they don't form as such any hydrogen bond with water, right? Alkanes being non-polar molecules are soluble in non-polar solvents because like dissolves like, right? So non-polar will dissolve non-polar only. So this is soluble in benzene, ether, chloroform. However, they are insoluble in polar solvents like water. If you talk about the polar solvents like water, they are insoluble. Why? Because polar will dissolve only polar molecules. Their solubility decreases with increase in their molecular weight. So solubility, if you talk about, the solubility decreases with increase in the molecular weight. So as the molecular weight will increase, the solubility will decrease, reason being the van der Waals interaction. If this part is very large because of the steric hindrance, right? Because of the steric hindrance, if alkyl part is very large, alkane is very large, so that's why the van der Waals forces will decrease, right? That's why solubility decreases. Next is melting and boiling point. Melting and boiling points increase with molecular mass and decreases with number of branches, right? So melting point of alkane having odd number of carbon, right, is less as compared to alkane having even number of carbon because of the symmetry, right? More is the symmetry, see, more is the symmetry, more will be the melting point. In even number of alkenes, if you talk about, see, why this is so, because if you talk about even number, 1, 2, 3, 4, 5. If you even number 1, 2, 3, 4, 5, 6. So it will give you symmetry. This is first molecule, second molecule can get here, third molecule can get here, fourth molecule can get here. They can arrange themselves in a symmetry, right? Okay. Thank you. Welcome, welcome, welcome. Right now, because of this symmetry here, as you can see, this is very symmetrical. That is why the melting point is high. But here, if you talk about this thing here, here there is no symmetry as such. 1, 2, 3, 4, 5 molecules here. Right. So, for example, let's talk about, you say, ma'am, symmetry is present here. Ma'am, symmetry is present here. But what will happen? What will happen if it is like that? 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 Some molecule is present here. Now this symmetrical, basically they are not that much symmetrical as compared to even number of alkane. That is the reason, because of the less symmetry, their melting point is less. Okay, so odd will have less melting point as compared to the even. Okay, okay guys. Now this, as I told you, right, that intermolecular interaction in crystal depends not only upon size but also depend on how they fit into the crystal size. That means symmetry. Both methyl groups are directed on same side. That is why there is no symmetry. Here they are on the opposite side. That is why there are symmetry, as you can observe here. Right? Okay. They are symmetrical. Boiling point. Melting point will depend on the symmetry. Always and always remember this. But boiling point will depend on the interactions. So, if you talk about the interactions, here we have van der Waals interactions. No hydrogen bonding is present here. So, boiling point decreases with increase in branches. So, more is the branching, more is the steric hindrance. That is why, because of the hindrance, the forces will get decreased. That's why solubility will decrease here. Right? Okay. Next are the chemical properties. Okay, this most of the properties so we have done. Okay, shall we start? Okay, guys. Okay. Now, here we have substitution, combustion, controlled oxidation. These four are so very, very simple. First, you will see these three reactions. Okay, substitution we have already done in a previous lecture. That we, do you remember that reactivity selectivity principle? Right? Do you remember that reactivity selectivity principle? Right? That I have already taught you, because I knew that this lecture is going to be long. So to make this lecture a little bit shorter, that's why I've already done that in reactivity selectivity principle. Those who have not watched it, right? Please go through haloalkanes, halorenes, because that is a very important concept, right? Very important concept for your JEE, right? Okay. What about tautomerism and metamerism? Bacha, that will be taught in isomerism. Okay, that's a topic of isomerism. Okay, yes. Now, have you not completed isomerism on this channel? Not completed? Have you not completed isomerism on this channel? What? Have you not completed isomerism as well? Huh? Tautomerism, metamerism, go and search the video, you will find that. Otherwise, I am going to teach you in the previous year questions also. Right? Okay. Now, first is substitution reaction. That means you have RH. This will be substituted by something else. Let's say X. Right? Substitution reaction happens in the presence of sunlight. Right? Basically, this is according to the free radical mechanism. This will happen in the presence of four substituents I am writing here. Cl2 or H mu, Br2 or H mu, NBS. Right? These are the things in which substitution reaction will happen. Okay? These are the cases where substitution reaction will happen. Okay? Okay? Now, you just need to write it down here. Right? Now, as you can see, one or more hydrogen atom of alkane can be replaced. A mixture of alkane chlorine is expected to become just like this. Here, hydrogen is replaced by the chlorine, replaced by chlorine, hydrogen replaced by chlorine, hydrogen replaced by chlorine. Right? Okay? Okay. Now, this also we have done in previous lecture, that the ease of substitution. See, because here the intermediate is a free radical, and we know that the stability of free radical is 3 degrees more stable due to the, why 3 degrees more stable? Due to plus I effect. Plus I effect, or you can say this effect, because of the plus I effect, right? Because of the electron donating power of methyl groups, 3 degrees more stable than 2 degree, then 3 degree. Because this is the order of intermediate stability, this will be the order of preference of the substitution, right? Now, I told you one more thing, that the reactivity of halogen will be F2 is more reactive than Cl2, then Br2, then I2. But we will not study F2, we will not study I2, because I2 is going to reverse back the whole situation, and F2 is a very explosive in nature. I2 is very slow, F2 is very explosive. That's why we only study Br2 and Cl2. Cl2 is reactive, that is why it is less selective. That is why we have studied the concept of reactivity selectivity principle. Br2 is more selective, it is always going to give 3 degree, then 2 degree, then 1 degree. It is always going to replace 3 degree, then 2 degree, then 1 degree. Right? Okay, the major product will be 3 degree, then 2 degree, then 1 degree. Now students, tell me, do I need to repeat it? Do I need to repeat it? Because we have already done this in haloalkanes, haloarenes. Right? Fluorination of alkane is so violent that results in cleavage of C, all the bonds. Iodination, iodination is a very, sometimes things happens, right? Okay, iodination is a very small and a very reversible reaction. That is why it is carried in the presence of oxidizing agents like these, so that this reaction can take place. This also we have already done. This also we have already done, right? Chain reaction, it will give Cl first, then this is the chain initiation process, this is chain propagation, more free radicals will be formed, this is chain termination, right? This we have already done. Okay, now let us go to the combustion reaction. Okay, okay. Combustion reaction, as you can see here, combustion means in the presence of oxygen, what are the reaction that will happen? In the presence of oxygen and heat, carbon dioxide is formed, H2O, and heat is formed. That is, it is an exothermic reaction. This is a general reaction that I have written here, that if you have alkane, that is CnH2n plus 2, oxygen, if it is, this is a general reaction, it is 3n plus 1 divided by 2, then this is NCO2. I think now it is visible to you, right? This is plus n plus 1 H2O and plus heat, right? Okay, I think now it is visible to you, because earlier I think it was not visible only. Now this is visible, right? Okay, or still it is not visible? If it is still not visible, then I'll just write it on the next page. Okay, I'll just write it on the next page. See, we are saying that if your alkane is CnH2n plus 2 plus you have 3n plus 1, 2 oxygen, then what amount of carbon dioxide and water is formed here, right? Then what amount of carbon dioxide and water is formed here, right? Okay, so this is n amount of water and n plus 2 amount of carbon dioxide, right? Okay, okay, so sorry, yes, n amount of carbon dioxide, n plus 1 amount of water. Now I'll just give you the same thing for alkene and alkyne, right? Because it is same only. See, for alkene you have CnH2n plus 2, right? For alkene you have CnH2n. For alkyne you have CnH2n minus 2, right? Okay, now just change everything according to that. Here you have, because it is plus 2, that's why we have added plus 1 here. Now don't add that plus 1. Here you have subtracted minus 2, so from here you can subtract minus 1, right? Here carbon dioxide will remain the same, but water will change. It is N plus 1, here it will be NH2O, and here it will be N minus 1 H2O. Okay? Okay, guys? Okay? So this is basically, I don't want to do that again and again, right? Just from one way only, you just understand the general reactions here for alkane, alkene and alkyne. Okay? Okay, guys? Now, due to evolution of large amount of heat during combustion, they are used as fuels. Okay. Next is incomplete combustion. Incomplete combustion of alkanes with insufficient amount of air and oxygen form carbon black. That is this particular carbon. Now again, I think this is not visible. Just write it here. CH2 in the presence of incomplete means in anaerobic conditions where oxygen is less available. So they will form carbon black in with the release of, because delta H is negative. They will give you the heat here, right? So this is incomplete combustion, right? Full oxygen is not provided here, right? Okay. Now what is controlled oxidation? Everybody, what is controlled oxidation? Various conditions, different products are formed. Alkenes on heating with regular supply of oxygen at high pressure and suitable catalyst, various products are formed. Now these three are very, very important reactions, right? Very, very important. Very, very important. These are controlled oxidations. Directly they can ask you this. Basically with methane, say one step ahead. This is methane with oxygen in presence of copper. It is going to give you alcohol. Methane with oxygen in presence of molybdenum oxide, it is going to give you aldehyde. Now for carboxylic acid, this in the presence of manganese acetate, it is going to give you carboxylic acid. Alcohol, aldehyde, carboxylic acid. This is copper, molybdenum, manganese acetate, right? Okay. So basically, don't remember the full-fledged thing here. Okay, this is this. They can just ask you the reagent here. So just get an idea about the reagent. Okay, here it is molybdenum, here it is manganese, here it is copper. So just remember comoman. Comoman. It is alcohol, aldehyde, carboxylic acid. Comoman. Okay. Comoman. So it is your alcohol, aldehyde, carboxylic acid. Comoman. Alcohol, aldehyde, carboxylic acid. Okay. Just remember this thing. Okay. 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 Now, let us see the controlled oxidation, one more reaction here. Potassium permanganate readily oxidizes a tertiary hydrogen atom to hydroxyl group, right? A tertiary, this is the tertiary alkane. That hydrogen atom is oxidized to alcohol, right? So basically, tertiary means this H here, this CH3 here, this CH3 here, this CH3. We know that this is your tertiary hydrogen atom because it is connected to that carbon which is also connected to 3 more alkyl groups. So this is your 3-degree alcohol. This hydrogen is connected to that carbon which is connected to 2 more carbons. Sorry, it is connected to that carbon which is only connected to directly 1 carbon. So it is 1 degree. It is also 1 degree. It is also 1 degree. Right. So here answer is, here this 3 degree will be replaced by OH. Right. That is your controlled oxidation for the 3 degree alcohol in the presence of KMnO4. Right. Okay. Understood. Next are simple reactions. First is isomerization reaction. That means one thing will be converted to other. That means N-butane is converted to isobutane. See, hardly they will ask you this question, but in JEE Advanced I can expect anything, right? So that's why just remember the catalyst here, that in presence of AlCl3 and HCl, isomerization, that means one isomer can be converted to the other isomer, right? Okay, then we have For example, isomerism is also held by heating alkane with AlX3 plus HX or X or Al2SO3 or H2SO4. So any of these things reagent can be used here. That means ultimately they need aluminium 3 positive either with X or with SO4, right? In the presence of an acid, If you have these conditions at elevated temperature like 200 degrees Celsius, you will get the product. Okay, here N-heptane is converted to a branching, that is this is 2,2,3 trimethylbutane, right? It is converted to a isomer only, right? Okay, next is aromatization. Aromatization, everybody, what is aromatization? N-alkanes having 6 or more carbon atoms. If you have 6 or more carbon atoms, right? So for example, aromatization is when you are converting into aromatic rings, right? So firstly, though, you need to remember what is this reaction, then we will talk about what is the reagent. Reaction is that what will happen here, all of them will lose hydrogen atoms and it will give rise to the aromatic ring here, right? So what can be used here? Chromium oxide, vanadium oxide, molybdenum oxide, these are the reagents that can be used. Again, this is your JEE previous year question. Okay, yes. Now, N-alkane having 6 or more carbons, they can be converted to the oxides using the oxides of vanadium, molybdenum or chromium supported over alumina, right, at 773 Kelvin at 10 to 20 atmospheric pressure, right, dehydrogenated and crystallized, cyclized to benzene and its homologous. That means benzene and its derivatives can be formed here. Right, for example, you have N-heptane. So heptane means 7. So it is 1, 2, 3. Okay, I think it is drawn here. No, they have not drawn it here. So I'll just draw that for you. Right, so it is basically 1, 2, 3, 4, 5, 6 and this is the 7 one. Right, so what will happen here? Right, here, this will form the benzene ring, and this CH3 will left as it is, and this will give rise to the product that is toluene. This will give rise to toluene, that is a homologous of benzene. Now, if you have N-octane, right, then what can be formed? If you have N-octane, then definitely N-octane means 8, sorry, that will be 1, 2, 3. Basically, it's like this, right? And here you have 2 carbons like this. Okay, wait a minute. Here you should have N, no? Yes, like this. Here you had like this. So what will happen? What will happen here? Again, this cyclic ring, it will be converted to this benzene, CH3 and CH3 here. Or one more way is you have this 1, 2, 3, 4, 5, 6, 7 and 8. Now it will be converted to a benzene ring for this one, a benzene ring for this one, benzene ring for this one, benzene ring for this one. Rest is your CH2, CH3, CH2, CH3. Okay, so these things can be formed. Okay, now one more important question that also is asked in your JEE only, right? That is, if you have let's say this kind of product, reactant, 1 CH3 here, 1 CH3 here and 1 CH3 here, like this. Now what can be formed? Basically from this you will have the formation of double bond, CH3 here, CH3 here, CH3 here. That is, what is the name of this compound? Anybody in the chat box? What is the name of this compound? Anybody in the chat box? What is the name of this compound? Hmm. What is the name? Mesitylene. Okay. Yes. Now, I think that's it. Right. Now, reaction with steam. Okay. One more reaction, that is with the steam. Methane reacts with steam, right, in presence of nickel. It will give you carbon monoxide as the answer. Right. This method is useful in industrial preparation of hydrogen gas. Right. Okay. So there is one more reaction. If you remember this, this is a very important naming reaction, that is Reed's reaction. So what is this Reed's reaction, guys? This I have told you in haloalkenes, haloarenes as well. Darson reaction is when alcohol is converted to RCl. Reed's reaction is when alkane is converted to RCl. Right? Okay. Okay. Here we used SOCl2. Here we will use SO2Cl2. Here we have used thionyl chloride. Here we have used sulfuryl chloride. Okay, so that is the difference. Right? Very, very important thing. Usually students get confused in this thing. Right? So this is R, let's say CH4 here. If you add SO2Cl2, this will be converted to RCl. It is going to give the same byproducts, that is SO2 and HCl. This is called Reed's reaction. Okay, this is called Reed's reaction. Okay, guys, this is called Reed's reaction. Okay. Okay, everybody. Okay. Last is pyrolysis. The alkenes on heating under high temperature in absence of air and broken down into lower alkenes. So basically it's a very non-important reaction for you, right? But still go through that reaction once. We will never ask you this question. Alkanes on heating under high temperature in absence of air, and this what will happen? Pyrolysis means randomly so many products can be formed. If you use at 773 Kelvin, it will rupture all the bonds randomly. So there is no specific product that will be formed here. That is why we don't have to go in specificity here, right? So randomly rupture of CH bonds and catalyzed by oxide of chromium, vanadium, molybdenum. Rupture of CC bonds is catalyzed by silica, alumina and zinc oxide. This line you can learn, that CH bond are ruptured by chromium, vanadium and molybdenum oxides. CC bond is ruptured by silica, alumina and zinc oxide. Okay, this you need to remember. This line you can remember, but this is not important because it is randomly getting ruptured and making new products. Okay. Okay, guys. Everybody, is that clear or not? Everybody, is that clear or not? Everybody in the chat box. Okay. Okay. And also cracking. Very good, very good, very good. Ma'am, should I do NCRT reading after this? I would not advise you right now to read NCRT at this point of time. I would advise you to go through previous year questions of JEE Mains, right? Go through the previous year question rather than, because what NCRT, what they have written in NCRT, I have covered everything here, right? That is not going to give you any benefit at this point of time. If you will just 3-4 months away from, if right now I say this is August, then I would have advised you read NCRT after the lecture. But right now, after this lecture, I am going to tell you some of the, we are going to solve some previous year question based on alkanes and alkenes in the end of this lecture. After that, what you do, go and solve the previous year questions based on alkane and alkenes. Okay? Okay? Yes. Shall we start alkenes, everyone? Shall we start alkenes? Alkenes. And I'm not going to give you any break. Reason is, see, I know how important it is for you, right? So I am trying my best not to give you any break, right? But okay, I'm just trying my best in that. Okay? Yes. Yes. Yes, Charan. Yes, yes, yes. For aromatization also. Right? Okay. Now, let us see alkenes. Okay? Let us see alkenes. Now, everybody, green hearts in the chat box. Let us see alkenes. General formula of alkene is CnH2n, right? Alkenes are unsaturated hydrocarbons having carbon-carbon double bonds, right? Then, structure and bonding of alkenes, definitely we know that they have C double bond, this is H, this is H. Now tell me one thing, this is one pi bond, this is sigma. Hybridization of this carbon is sp2, this is also sp2. That is why these three angles are at 120 degree, these three angles are at 120 degree, right? So pi component arises from overlap of sp2 hybrid orbitals along with this, and the sigma component will exist because of the sp2 hybridization with s orbital of hydrogen. Pi will exist because of the sideways overlapping, right? Pi component is a sidewise overlap of two p orbitals, sideways overlapping. Region of high electron density attributed to pi electron. Now, why this is very reactive? Achha, why it is having below the plane, why it is having trigonal planar, that I have told you already, right? Now, why pi electrons? Because of sideways overlapping, they are loosely bound, and that is the reason. Okay, that is the reason what we will have. That is the reason we will have very reactive alkenes. That's why we'll see a lot of reaction of alkenes. Right? Okay, so this is the nomenclature, right? You can go through this, right? Common name ethylene, its common name is propylene, that this is butene, hexene. This is so simple, this you can easily do, right? Now, the isomerization. See, I'll just give you a recap of isomerization here because see, you all have done isomerization. So in detail, right, we have covered isomerization, right? So still we'll do what is basically isomerism. Isomerism, they give you structure isomerism. Cis and trans isomerism is the most important thing that you need to know here, right? So chain, first thing is alkenes can show only 4 type of structure isomerism. Sorry, this is alkenes, not alkenes. Alkenes. Alkenes show 4 type of structure isomerism. First is chain isomerism. This is normal. This is in branching. So they can show chain isomerism. Alkanes were showing only chain. This is showing 4 type of isomerism. First is chain isomerism. Other is position isomerism. Because the position of the double bond can also shift. This is at the last position. This is in the middle position. So they both have same molecular formula, but the compound is different because the position of double bond has shifted. So chain, position isomerism. Third is ring chain isomerism. This also, when you have a alkene, it can shift to the cyclic alkane and the formula is same. This is also having CnH2n formula. Its formula is also CnH2n. So the formula is same for both of them. That's why they show ring chain isomerism also. Last and very important is geometrical isomerism. Geometrical isomerism, that is because of the spatial arrangement, right? So now around the double bond, how they are spatially arranged, that will give you cis and trans, right? Very simple thing I'll tell you. Don't go through all these points because this is in hi-fi language written. Okay, just do this thing. 3, 4. The condition is that 1 should not be equal to 2 and 3 should not be equal to 4. Only then they will show geometrical isomerism, otherwise they will not show any geometrical isomerism, right? Okay. Only this is the case, and on geometrical isomerism also they ask you the questions, okay? But geometrical isomerism is a topic of isomerism, right? Here I am just doing a recap of that thing, right? Okay, now everything that I have written here, I have already told you in that concept, right? Acha, restricted rotation, we know that restricted rotation is there in cycloalkanes and alkenes, right? That's why. Acha, one more thing that we will discuss tomorrow. Acha, there is one question for you for tomorrow, okay? Shall I give you that question? Alkane do not have restricted rotation. That's why they show conformers. Why they show conformers? Because in conformers there is no restricted rotation is required. They should move like this. Like they should be like they should change the position, not the position, they should change the flexibility of the bond. But here the rotation is restricted. That means multiple bond is making the bond restricted. That means double bond and triple bond both are restricted. Then why? Very, very important question. Double bond can show geometrical isomerism, but triple bond cannot show geometrical isomerism. A very simple answer. Easily they can ask you this, right? Why alkynes, though they have restricted rotation, still they will not show geometrical isomerism. Okay, that is your homework. I'll see how many of you are able to answer this in the comment section. Okay, yes. Okay, now let us see the next one. How come cis and trans in the starting of this lecture only I told you. This so I know everyone know, hai na? What is cis, what is trans. Now tell me why this is not showing GI, because this is equal to this. This is equal to this. That's why there is no GI. Here X is not equals to Y is not equals to S. So this is showing GI. Okay. So in GI, you just need to remember this thing, that this 1 should not be equals to 2, 3 should not be equals to 4. If this is not equal but this is equal, it will not show. If this is equal, this is not equal but this is equal, it will not show. Both should be not equal to each other. 1 can be equal to 3, 2 can be equal to 4. But these two cannot be equal, these two cannot be equal. Okay? Okay, guys? Okay? Next is, okay, this we have already done. Stereoisomers, two types basically. Two types of geometrical isomers, cis and trans. Cis is when they are sitting next to each other. Sisters are always sitting next to each other. Trans means opposite. When the same atom is on the opposite side, that is called trans. Okay, I am so sad that we have less time. That's why I am not explaining you in that much detail, right? So, but yes. Those students, I'll just see, those students who don't know what is stereoisomer, I'll give you one advice. See, on Vedantu NEET English, I have covered it on the level of JEE only, right? So, if you are like not able to understand stereoisomer, you are still confused, trust me on that. I have covered on the level of JEE means, right? Advanced, I can say, because right now you need JEE means. You don't need JEE advanced level right now, because we need to clear firstly this January attempt. Right? So that's why I'm saying that go through that lecture on Vedantu NEET English, because right now I'll be focusing on the questions more after this. Right? I can't do the full organic chemistry in such a short period of time, because I just on this channel I landed I think 10-15 days back. Still I have taught you like everything, all the chapters of organic chemistry except for GOC and isomerism. So I would advise you go through GOC. GOC so I'll teach you here also. But go through isomerism. What if I am not able to take the lecture here? So go through that lecture. Okay? Yes? Okay. Now, next is alkene can be prepared by this chapter, by this method. Now, this is from alkynes, from alkyl halides, from vicinal dihalides, from alcohol by acidic dehydration. So one by one we will see all of them. First is Lindlar's catalyst, preparation from alkynes. How you will prepare this from alkynes, right? So this is basically from Lindlar's catalyst, right? How you will prepare this? What is Lindlar's catalyst? When you add hydrogen in the presence of some in the presence of a poison, right? For example, PbSO4 or maybe quinoline, okay, or maybe CaCO3, right? Or maybe directly they can write here poisoned by sulfur, right? Anything can be written here, or they can directly write Lindlar's catalyst. Okay, so now this catalyst is used here because we want to stop the reduction at alkene only, right? So in this process, we have the formation of cis alkene, a very, very important thing, right? But if you have Birch reduction, anybody in the chat box, if you have Birch reduction, this is Birch reduction. In case of Birch reduction, you have the formation of transalkene, very, very important question. Okay. So now in Birch reduction, again you will add hydrogen, but here you will use sodium or lithium in presence of liquid ammonia, that is called Birch reduction. In Lindlar's catalyst, cis is formed. In Birch reduction, trans is formed. BT. You always say na BT, 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 bad trip, BT, BT, BT. So it is Birch trans, Birch trans. Okay. Now, next is alkyl halides react with alcoholic. Now, second is alkyl halides. If you react alkyl halides, that was from alkyne. Right now, we are doing the preparation from alkyl halides. What will happen with the alkyl halides? Right. So, from alkyl halides, react with alcoholic QH and NaOH, eliminate one molecule from halogen acid to form alkenes. Let us see how. This is having beta elimination reaction. Let us see how it is done, right? So, in the presence of alcoholic KOH, from the alpha position, you will have the elimination of halogen. On the beta position, you will have the elimination of hydrogen. This is called Dehalogenation reaction, right? And you will have the formation of alkene here, okay? Alkene will be formed in this case, right? Okay. Then rate of halogen atoms. Now see, rate due to the halogen atoms. So more easy it is to break this carbon halogen bond, more will be the rate. Now we know that carbon fluorine bond is stronger as compared to carbon iodine bond. That is why iodine having the maximum rate, then bromine, then chlorine. Because down the group size increases, the bond length of carbon and iodine is also more as compared to carbon bromine and carbon chlorine, right? This is CCl, this is smaller than CBr, then you have maximum is for Ci. Fluorine is very explosive, so we are not taking it here, right? Rate of alkyl groups. Now one very important thing to see here, that here you have the tertiary, then secondary, then primary. Can you tell me the reason? Can you tell me the reason behind this? Anybody in the chat box? Anybody in the chat box? Can you tell me the reason behind this? Hanji, everybody. See, now this is your, I'll give you one question here, okay? I'm just going to give you one question. Here only I'm going to write the question. Side by side, guys, I'm giving you the question as well, right? Just give me a second. I think this is a good question. Now, I'm waiting for the answer why this is the rate, okay? I'm waiting for your answers here. I think, yes, this will be a good question, right? Now, why this is the, very good, carbocation stability, right? This is the order because intermediate is carbo, just remember intermediate is carbocation, that is why this is the order. Now, when they are saying that you are adding alcoholic KOH, now we know that carbocation is formed. So firstly, what you do, instead of OH here, it should be Cl, right? It should be Cl. So what will happen? Cl negative will be eliminated firstly. So this will be this, and this is your methyl and this is your positive. When Cl negative will be eliminated, you will have positive here. Now, tell me, this is 1, 2, 3. This is connected to 3 carbons only. So this is the 3 degree only. So 3 degree carbocation is stable, right? That's why we don't need anything else. That's why the answer will be beta elimination. From beta position, hydrogen will be eliminated. And okay, one important thing to remember here, we have 2 beta position. This is also beta. This is also beta. Which alkene will be formed? 2 alkenes can be formed. This is either hydrogen can be removed from this side. Okay, hydrogen can be removed from this side. You will have the formation of this double bond here. Or hydrogen can be removed from this side. You can have the formation of double bond here. So it will be 1, 2, double bond, and this is methyl. Now tell me which is more stable. Which is a more stable alkene? Upper one. Why that one? More stable alkene. Which is more stable alkene here? Right? What, Rathi? Huh. Okay, so guys, firstly tell me whether this or this. What can be the correct answer? First one, second one, upper one. Why upper one? Always remember that your ZF alkene is more stable alkene, right? So which alkene will be formed? Which is highly substituted. This alkene has only 2 alkyl groups. This alkene has 1, 2. This alkene has 1, 2, 3 alkyl groups. So which is having more alkyl group? Which is having more alkyl groups? This one is having more alkyl groups. So this will be formed. This will be the major product. Okay, this will be the minor product. Got it? This will be the major, this will be the minor, because ZF alkene is more stable alkene. Okay? The one that is highly substituted alkene is more stable alkene. That is why this to everyone know that okay, this will eliminate, it will dehydrohalogenation, but this is where students get stuck. Okay, so these are the things that you need to focus on. Okay, yes everyone, got it? Why this is not the major, why this is the major, right? Okay. Now preparation from vicinal dihalides. Third is preparation from vicinal dihalides. Vicinal dihalides. Geminal means when halides are on adjacent position. Geminal means when halides are on the same position. Vicinal means when halides are on the adjacent position. Right, so halides are on the adjacent position. Now what will happen? Right, now you are forming alkanes out of that. That means dehalogenation you will do. You will take out this halogen from this side. Now tell me which thing will be formed. Vicinal dihalides in which 2 halogen atoms are attached on the adjacent carbons are heated. Very, very important. They are heated with zinc dust. An alkene of same number of carbon is obtained. This is called dehalogenation. Let us see a very, very simple thing. Just eliminate this thing, and on this position you will have a double bond. Basically what will happen? This will be eliminated, this will be eliminated, and you will have the answer as double bond here. Right? Just eliminate this thing here and attach double bond here, you will have your answer. Okay, you will have your answer, that is dehalogenation. So zinc dust is going to give you dehalogenation reaction. Okay, just remember this thing. Okay guys, okay everybody, okay everybody. Now here write one more thing, that what else they can give you here. What else they can give you here? Instead of zinc, they can also give you zinc dust CH3COH. They can also give you zinc dust acetone, right? They can also give you zinc dust ethanol, right? Okay, so these things they can give you, right? These are the other reagents that can be given to you, right? These are the other reagent which will do the same work as zinc dust here. Same product will be formed. Okay. Acha, now let us talk about geminal dihalides. Acha, from alcohol, geminal dihalides they have not talked about. Let us see from geminal dihalides, okay? From geminal dihalides, what will happen? From geminal dihalides, this is your third, this is fourth preparation, this is fifth preparation. From geminal dihalides, from geminal dihalides. Now you need to tell me what will happen with geminal dihalides, that if you have halogen on the same position, now what will happen? Now what will happen? Right? Now also dehalogenation reaction will obviously occur, right? But you need to tell me how this will occur. Okay? Okay? Now, see what will happen. This is carbon, this halogen is on the same place. Now, this is your zinc. Again, you are going to use zinc only here, right? Okay, this is the zinc. Now, this will happen but with two reactants, okay? Two reactants. Same thing will happen but with two reactants. So, I'll just showing you two different reactants here. This is CH, this is X, this is X, this is CHHH. Okay? Yes. Now let us see what will happen here. Now everybody in the chat box, let us see what will happen here. Okay? So this is your CH, this is X, this is X. So what will happen? Two halogens will be eliminated from this side. Right? Okay. Now, wait a second. Two halogens will be eliminated. This is H, this is H. Two halogens we have, right? So, it will give rise to CH3, CH2. Wait a minute. This is X, this is X, right? So, this will give you not completely alkene we need to form, right? So, for alkenes, if one halogen is liberated from this side, other will remain the same. So, alkene will be formed, but the halogen will stay as it is. If I replace one halogen from here, just give me a second, then this is CH3, this is C, H, this is double bond, this is C, this is again CH3. Now, in this position, you will have one halogen also, right? This thing will be formed here, right? This thing will, because after elimination of these two bonds, it will have a double bond here and 1, 2, 3, 4. This is how this thing will be formed here, right? है ना? अरे, so sorry. Yes. Totally forgot. Yes. Okay. So sorry. Yes, both will be eliminated because there is one sigma bond also, na? Haan. Both will be eliminated. Yes, both will be eliminated. If this is eliminated, this will give rise to one sigma bond. This will give rise to one pi bond, right? And here you will have CH3. This is CH3. The reaction is same for the formation of alkyne as well, right? So this is CH3. This is C. This is C. This is one hydrogen is as it is here. One hydrogen is as it is here. This is forming one sigma bond, right? And there is one pi bond formation, right? This is how you have the formation of alkene here, right? This is how you have the formation of alkene here, right? This is going to form one sigma and one pi bond here. Huh. There is an extra in the second carbon. Yes. Okay, so sigma and pi bond will be formed like this. Okay, got it? Got it. From vicinal also we have seen, from geminal also. Then fifth is preparation from alcohols. So from alcohols, basically it is a important, very, very important concept, right? That is dehydration. Now, dehydration can be done with heated with concentrated H2SO4, which is a very good dehydrating agent. Water will be taken out here. Like here, we will have beta elimination reaction. So, hydroxyl group takes out one hydrogen atom from the beta carbon. So, basically, this is your thing, right? This is the alcohol. OH will be eliminated, H will be eliminated, double bond will be shifted. You will have the formation of alkenes here, right? Okay, you will have the formation of alkenes here. Right, guys? You will have the formation of alkenes here. Okay, let me see if any reaction we are left with. Yes, let us do one very, very important thing here, right? One very, very important, because this is one of the most important concept, right? Okay, so let us do this. Firstly to write the catalysts here. Firstly to write down the catalysts here. Catalyst, because anything can be asked to you. Catalyst can be Al2O3, or temperature is also very important, right? Concentrated H2SO4 at 443 Kelvin, right? The temperature will be 443 Kelvin, because at other temperatures, this we have done in alcohol phenols also. We have done this, right? Do you remember we have done this in alcohol phenols, right? Alcohol phenols and ethers. We have done the same reaction, that how ethers will be formed, right? From the same reaction by the temperature fluctuation, right? Okay. Okay. Also, you can write down H2SO3, H2PO4, right? Okay, this also can be used here, H3PO4. Now, I am going to give you one question based on this, right? Because from here, usually question can be asked, right? A good question I will give you, right? So, the question is, you have OH here, you have OH here, right? And this is your triple bond. Now see, remember one thing, that carbocation is formed in this place, right? So what will be the answer? OH will be eliminated, right? You will have the formation of this 3-methyl group. This is your positive. Now guys, we know that this is a 2-degree carbocation. But if I do the methyl shift, I can easily get 3-degree carbocation. That means this is 2 methyls as it is. 1 methyl is shifted here from this place to this place, and this is my positive, right? Now, what we will see from here, very important thing, what we will see from here, that now you are going to take, like basically you are going to take out hydrogen from here. So this is the hydrogen at the beta position that you will have, right? So this is your carbocation, this is the beta, or this is the beta position. Hydrogen, it can replace either from this side, because here also it has one hydrogen, either from this side or this side. These two are symmetrical only, so either this side or this side. This is a rearrangement. This is a rearrangement, okay? Now, again the question is, from this side or this side. Now tell me guys, because of the Sedzeff rule, which will be formed? Sedzeff rule, the two possibilities we have. Either we can lose this hydrogen and double bond can shift here. It will be methyl, methyl, and this is methyl, and this is one double bond. This can be formed, right? Or this is your, either this hydrogen will be eliminated, double bond is shifted here, this is double bond, 1 methyl, 1 methyl, 1 methyl, 1 methyl, either this can be formed. Now tell me which is more stable, which is more highly substituted. This is having 4 alkyl group, this is having only 1 alkyl group. To this double bond there is only 1 alkyl group, others are hydrogen only. So this is the minor product, this is the major product. This is the major product. Okay, this is the major product. Got it? Everybody understood or not? Everybody? Yes, second one is the correct answer. Yes, very good guys. Second one is the correct answer. Very good. Now, let us see this again. Physical properties of alkenes. Okay, let us see the physical properties of alkenes. Yes, what is the doubt? What is the doubt? What is the doubt? Achha, I'll give you one very interesting question, okay, based on this, based on ring expansion, which is a question of JEE advanced level, right? Good question, okay, good question. Okay, so this is your OH, right? This is OH. And here you have, let's say you have this thing. Okay, 1, 1, 2, 3, 4, 5, pentane ring. Now see this very carefully. Here the concept will be, rearrangement will occur, but because of ring expansion and contraction. Now it will get, OH negative will be eliminated. It will give positive here. And this is the thing that you will form. Now do you remember one thing? That whenever you have, on this ring you have positive charge, right? It will expand or contract. There will be ring contraction, right? If you have not on the ring but outside the ring, just one carbon away, you have the positive charge. There will be ring expansion. Now tell me, both things are available on this ring. That is why this is a good question of JEE advanced level, right? Also this can be asked in mains as well, right? You never know, right? So it's a good question, okay? Now this is a positive charge. On the ring, 6-membered ring is very stable. But we know that the problem is with this 5-membered ring, which is not at all stable, right? Which is not at all stable. So can I say that this pentane ring is having a positive charge outside this ring? है ना? It is having positive charge outside the ring. If I focus only here, if I focus only here I am focusing, right? That means ring expansion can be done. For ring expansion, always remember 1, 2, 3. 1 is this one, 2, and this is the third, right? So what will happen? The bond between 2 and 3 will break, or you can even call this as 1, this as 2, this as 3, whatever you feel like. Now the bond between 1 and 2 will break. Break the bond of 1 and 2, join 1 and 3, and this positive charge will be attached to 2. Understood what I just said? Break the bond of 1 and 2, attach. I'm going to do this in front of you only. Okay, I'm just writing this as it is here. I'm writing this as it is here. This is pentane. This is pentane. This is the positive charge. This is 1. This is 2. This is 3. What I am telling you? Break the bond of 1 and 2. Break this bond. Attach 1 and 3. Attach 1 and 3. Attach 1 and 3. Okay, I have attached it. Positive charge on the second ring. Understood? That means I can write this thing as, I can write this expansion as, to make it in a, look it, so that anybody who sees this, they can also understand what we are writing. This is a 6-membered ring. 1, 2, 3, 4, 5, 6. So just draw a 6-membered ring here. Now you have a positive here. Now everybody tell me, are you guys able to understand this? From this to this, how I made this? From this to this, how I expanded the ring expansion, and how I formed this. These two are the same thing only. It's just a way of writing is different. Okay. Very good. Bicyclohexane is formed. Very good. Now, We know that beta is here also, beta is here, this is also beta, beta is this also. So three options we have. Three options we have, right? What can happen if I replace hydrogen from this side? Double bond will shift here. That means I'll have the formation of this benzene, not benzene, this cyclohexene, and double bond will be shifted here. If I replace this hydrogen, then it will shift here. It will be this thing. It is formed like this here, and double bond will be present here. If I replace this thing, this double bond will be shifted here. Then answer will be 2 hexene rings, right? Double bond is shifted here. That means here. Now tell me which of them is more stable. Now tell me which of them is which is highly substituted. Which is highly substituted? Here you have 1, 2, 3, 4 alkyl group. Here you have 1, 2, 3, only 3 alkyl group. Here 1, 2, 3, 4 alkyl group. Here 1, 2, 3 alkyl group. So maximum alkyl groups are present here. So the answer will be, this is going to be the correct answer. Okay. This is going to be the correct answer. Okay. So if they really want to ask you good question from here, they will ask you this kind of question. Okay. This is not the correct answer. This is not the, this is the correct answer. Okay. Understood everybody? From this you have this answer. From this you have this answer. From this you have this answer. Okay. Yes, first one is the major product. Okay. Understood everybody? Everybody? Okay. Now physical properties of alkene. Okay. Physical properties of alkene. Everybody ready? Physical properties of alkene. Ready for the physical properties of alkene? Ready for the physical properties of alkene? Acha, 2-3 reactions we are left with. Let's do those 2-3 reactions. Which was a number here? The number is 5. This is the 6th one. We're also left with 2-3 more reactions, right? 7th is coals. Ma'am, how can coals make alkene, ma'am? How is this possible, ma'am? So I'll give you one example here. Example is RCH2COOH. RCHCOOH. Right? Okay. So it is already having 1, 2, 3. So it is having one hydrogen here. Right? So this is the thing. Now, what will happen here in Kolbe's electrolysis? Right? What will happen? We know that the answer is usually just leave this COH and you make this bond. Right? Now, what you need to do in this case? Eliminate this thing, eliminate these two things and place a double bond here. Instead of this, you will have a double bond here. Right? Instead of this, you will have a double bond here. Answer will be RCH double bond CHR. Okay? This will be the answer. Okay? Okay, guys. Just eliminate these two things and have the answer. Okay? Because see what it was doing. Even in alkane, what was happening? This was RCHCOOH. What it was doing? This thing was being eliminated and you had the formation of one single bond with hydrogen was attached here. So when you attach hydrogen bond with single bond, then it is alkane is formed. Here also you are attaching one single bond. Right? Here also you are attaching one single bond. So you are doing the same thing only. You are attaching one single bond only. Just remember it like that. Okay? Yes? Now, another important reaction is Wittig reaction. Okay? Other important reaction is Wittig reaction. Wittig reaction. Okay, guys? Okay? Now here we use phosphorus. halide. Right? Okay. What is phosphorus halide? What is phosphorus halide? Phosphorus, P, PH3, and this is CH2. This is called your phosphorus halide. Okay, now as you can see here carbon is having 1 to only 3 bonds, so it will be negative, it will be positive here. Now what will happen, you will have a ketone and it will just exchange two positions here. For example, you have a ketone, don't get into mechanism or anything, nothing like that is in your syllabus. So it is P positive, CH2 negative, right? Just remember this thing, what will happen, what will be the answer. So what will happen, it is just going to replace this thing here, okay? I think for that I should write the full-fledged formula here. P, pH, 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 positive, CH2 negative. Now just exchange these two positions, okay? Are you writing it down? Are you writing it down? Huh? Just exchange the position. This will be exchanged here. This will be exchanged here. So it will be R, C, R dash, CH3, right? Because it will also again to complete the valency, it will be CH3. And here it will be P, PH, 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 C. Wait a minute, this should be C double bond O. Huh. Double bond O, yes. It will be double bond O. Now, what you will observe here, phosphorus wants to make 5 bond, okay? So, here it is making 5 bond. Here carbon is making its own 4 bonds, right? So, basically here also hydrogen will be added, okay? So, basically just remember one thing, that this will be attached here, this will be attached here. When this is attached here, this is CH3. When this is attached here, it is double bond O. Okay. 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 This is your Wittig reaction. There is one more reaction. That is pyrolysis reaction. Right. So let's not skip anything here. Right. Let's do pyrolysis reaction also. Pyrolysis of ether. Okay, so I'll just tell you how the bonds will break here. Okay, so let us see how the bonds will break here. Okay, it's not ether, it should be ester. Pyrolysis of ester. So I'm just making one compound here. Ester means C double bond O, O. Right? Let us make a compound, that is CH3, CH2, CH, and here Hoffman product will be the answer, okay? We'll see how the Hoffman product will be the answer, right? Hoffman product is the only answer. Hoffman product means less substituted will be formed, right? So now here what will happen? We are supposed to break these bonds here, right? Okay, so what will happen here? Let us see. We know that, let's write this here only so that we are able to understand the mechanism as well. The electrons are going to jump here, right? Okay, because of this beta at this position, this hydrogen will be attracted towards this one, right? Okay, now these electrons are shifting here. That is why what will happen, this pyrolysis means to break the bonds. This bond will shift here as C double bond O. So here what you will have, CH3, C, this is OH, and this is double bond O, right? This thing will be formed. This thing will be formed. What you will be left with, this bond will shift here, and here you will have CH2 double bond CH R. Now here what you will see, Hoffman product is formed, which is least substituted. है ना? If you see that which product is more substituted, if you have this kind of alkene, that is more substituted, right? If not this alkene, if you have R double bond here, this would have been a better choice, right? R double bond, then you have C, then you have CH2. This would have been a better choice, right? But here Hoffman product is formed, which is having least substituted alkene. Okay, least substituted alkene is formed in this case. So I think apart from this, though, I think we have done all the reactions only, right? So now let us see the physical properties of alkenes. Colorless, have no characteristics odor, right, except ethene, which have pleasant smell. Okay, then lower members, that is 2 to 4 are gases, 5 to 17 are liquids, higher are solids. Then boiling point, melting point, specific gravity show regular increase with increasing molecular weight, right, because of the heaviness. Alkanes are less volatile as corresponding alkenes, right, alkenes. Like alkanes, these two are soluble in non-polar solvent. Reason being because they are also non-polar, so they will be soluble in non-polar only. Then greater the number of attached, now they are saying greater the number of attached alkyl groups, highly substituted. Now, this is what I told you, that highly substituted are more stable usually. Only in some cases like Hoffman product is formed, right? Okay. No, I would, if you want to get scared, then you can watch. You can watch if your basics are clear, right? Sometimes even 12 students don't have their basics clear. Sometimes I see 11 students, their basics are really, really clear. So it depends. Okay. So now highly substituted have more stability, right? Okay. That is called Setzer rule. That is why highly substituted alkenes are formed. Okay. So now we are left with the properties of alkenes, right? Okay. Then we will see the questions. Yes. Not far away from the questions, right? Maybe 20-30 minutes away from the questions. Okay. Yes, everyone. Okay, Jayashree. Okay, Jayashree. Huh. Now, chemical properties of alkenes. Okay, let us see the chemical properties. Alkenes are rich source of loosely held pi bonds. That is why they are very, very reactive. Electrophiles add on carbon-carbon double bonds. That is why they show addition reactions of alkenes are electrophilic addition reaction, because they have a electron density over here, right? That is why electrophiles are attracted towards this bond. Okay, right? Now, there are four type of addition, firstly four type of reactions we will see. First is addition, oxidation, ozonolysis. All are very, very important. Trust me, this is the most important topic. Properties of alkene, all the questions that I'll show you, right, mostly they are from properties of alkenes. So right now, even if you are here for questions you will be only able to understand if you understand what I'm teaching you here, right? Okay. If you are like, okay with ma'am, I already have good knowledge, I don't want to revise anything, then you can come after 15 minutes, 15 to 20 minutes, right? Okay. Now, let us see addition reactions firstly. Addition reaction, addition of H2 on alkene. Now, bacha, I am going to again tell you the same thing that I told you. This is going to solve most of your questions, right? Okay. That is, let's make a table. Let's make a table. Very, very important table it is, right? Very, very important table it is, right? Divided into three parts, right? Divided into three parts. Let us see. This is cis. Okay. We are making a table. This is cis. This is cis, trans, cis, trans. Addition, if it is anti, let's say syn, anti, anti. Mostly they will ask you these kind of reactions, or they will ask you direct direct question will be asked. Cis means positive on the same side, trans means negative, cis positive, trans negative. Syn means addition on same side, syn means addition of same side, that is positive. Anti means negative, negative. Now just multiply this thing. Positive, positive will give you positive. Negative, positive will give you negative. Positive, negative will give you negative. Negative, negative will give you positive. Now, which product will be formed? Erythro means on the same side. Therio means on the opposite side. Erythro means, therio means on the opposite side. Erythro means on the same side. Same side means this kind of product. You will always have alkanes, right? So same side means this kind of product. Opposite side means this kind of product. Right? Understood? Now this will be useful throughout these reactions. Okay? Understood this thing or not, everybody? Everybody? Now let us start with the reactions. Now I'll tell you what are the things that you need to focus on. In the mechanism, you don't need to cram the full mechanism. Focus where you have syn addition, what are the important points, okay? Addition of dihydrogen. Addition of hydrogen on alkene and alkynes in the presence of finely divided platinum, nickel, platinum to form alkane. This process is known as hydrogenation. This we have done before also, right? That from alkynes you will have this. Now this I have told you that this is a syn addition. This is a syn addition. Okay. So here whenever you will make the products, that will be a syn product will be formed here. Okay. Yes, this is a syn addition. Just remember this is a syn addition. Okay. Question also, have we done question based on this or not? Guys, in the starting of the reaction where I was teaching you, starting of the chapter when I was teaching you alkenes, I taught you this thing, how we will have erythro and therio product in the starting of the lecture, right? Okay, so this we have done today itself. Next is addition of halogen. Now this is a very, very important, very, very important, because it is showing an anti-addition. Now, what is the intermediate? That is important for you, right? Halogen except iodine adds up to alkene to form vicinal dihalides. That means carbon, carbon, this is X, this is X. Okay, that means halogen on the adjacent positions. Reaction with bromine is basis for the test of alkenes. Reddish orange color. Now, this is also called test of unsaturation. Right? This is also called test for unsaturation. In the test for unsaturation, bromine vapors are of reddish brown color. Right? When this reaction will happen, the reddish brown color of bromine vapors will go. Right? It will turn into colorless. That is why this is called test for unsaturation. If you use bromine vapors, test for unsaturation. Okay. Now, let us see what will happen. You will add halogen in presence of CCl4. You will have the vicinal dihalides. Reactivity, definitely F2 is reactivity order will always remain the same. For halogens, this is a reactivity order, right? That's why we discuss chlorine and bromine. Iodine is very slow and fluorine is very fast, right? Now, halogen, this we have done. This the same thing is getting repeated, no? Yes. Now, let us see, okay, if you add Br, then we will have 1, 2 vicinal dihalides. Again, we will have vicinal dihalides is formed, right? Now, let us see this thing here. Addition of halogen halides. Wait a minute. Wait a minute. Wait a minute. Wait a minute. I think it is not shown here. So, I'll just write it myself here. Okay, just give me a second. I think I'll just write it here one thing on the blank page, that it is an anti, or I should write it here only. Why to write on blank page? Hai? I should write here only. I'll just write here only. It is an anti-addition. It is an anti-addition. Right? Anti-addition means from one side to other side. Now, why this is an anti-addition? For example, this is your alkene. Right? Okay, this is your alkene. Now you are adding Br2, right? What will happen in the slowest process? What will happen? Just remember this thing, okay? You don't need to get into the full mechanism. This pi bond will break and Br will be added. This is R, this is R. That's why when other Br negative is attacking here, if this is the first attack from this side, this attack will happen from the opposite side. That is why this is an anti-addition. Understood why this is an anti-addition? Right? Okay. Because here halonium ion is produced. Right? Okay. Intermediate is halonium ion. That is the reason. It is already blocked here. So Br can attack from the opposite side only. Right? So that is why anti-addition. Okay. Third is addition of hydrogen halides. Okay. Addition of hydrogen halides. How many times we have done this, guys? How many times? Tell me. Markovnikov, anti-Markovnikov rule. How many times we have done this? Halogen halides means HX. Addition of HX here, what will happen? Right? So basically, HX, the reactivity of HI is greater than HBr than HCl. Why? Because down the group, this is fluorine, chlorine, bromine, iodine. Down the group size will increase, hence bond length will increase. It is easy to break the bond of HI. Right? Then let us see the reaction. What is important to note down here? When we are adding here, it is using Markovnikov rule for unsymmetrical. That means negative, rich to poor. Negative part will be attached to the less number of hydrogen. Right? Okay. But. If you are adding addition of this reaction, it is used in the case of Markovnikov addition, right? As you can see here, HBr we are adding, right? Now here it is having same number of hydrogen only, so this is symmetrical. This is basically symmetrical, okay? So in symmetrical, don't worry, but in unsymmetrical, you need to worry, right? Addition of this into unsymmetrical alkene, right? You will use Markovnikov rule or the new kind of a thing that we say about this Markovnikov rule. We don't say Markovnikov rule. We say firstly make carbocation, then rearrangement, then you will get your answer. Okay. Firstly carbocation, rearrangement, then you will get your answer. Okay. This is a modern version of Markovnikov rule. Okay. Now, okay. So from here, there we can easily see it is not a complex molecule. So easily we can answer. This is also very, very important. The questions are asked on this. I know it's very simple, but yes, the questions are asked in the chain reactions. Today only we will see. This is the negative part, this is the positive part. Negative part to less number of hydrogen. That means this is the major product that is formed. This is the minor product. Okay, this is the minor product. Now, let us see what if this is a mechanism. We know that in mechanism you have the formation of carbocation. That's why I told you firstly make the carbocation, then rearrange it. Right? There is always a reason that when I am telling you these little tricks, no? When I am telling you these little points, you need to remember these points. Why? Because these points are going to solve your JEE questions, okay? These points will solve your JEE question. Usually students just cram this thing. This is a level of board, that Markovnikov rule. The level of JEE is that carbocation, then rearrangement, then answer will be there. Okay? Now, next is you have mechanism, right? Mechanism, rate determining step will tell you. That is why carbocation to more stable carbocation, that is rearrangement you will do. That is rearrangement you will do. Ring expansion or ring expansion also can happen here. Right? Okay? Yes. Now, this is Markovnikov rule, right? This is Markovnikov rule. This we have already seen. To understand anti-Markovnikov principle, let us understand the following thing. Anti-Markovnikov means when you are adding the peroxide. peroxide. So basically in peroxide there is formation of free radical. They can also ask you why in peroxide you have this kind of, you have opposite thing. Why? Because what is anti-Markovnikov, guys? In anti-Markovnikov, negative. See, Markovnikov is a good world, okay, in which rich is going to the poor person. The one who is more electron density will go to the less number of hydrogen. But in anti-world, right, what will happen? Rich will go to rich. That means a negative will go to more number of hydrogens. More number of hydrogens, right? One more thing about anti is that only for HBr. HBr to we are not discussing, HF to we are not discussing only because the reaction will be explosive, right? Very reactive. Second is, if we talk about HBr, HCl and HI, HCl and HI will give the same product in Markovnikov and anti-Markovnikov. You can write it here. HCl and HI give same product in Markovnikov or anti-Markovnikov It doesn't matter. They will give the same answer. Okay? Same answer they will give. Right? Now, it is free radical. Now, next is this peroxide. Now, you don't need to cram this again. Just see how it is giving you the free radical mechanism. Here, basically, this peroxide linkage will break and it will give you RO. We know that in free radical you have HELPR, right? H means heat, E means electricity, L means light, UV light, P means peroxide, R means radical. So once you have peroxide, it will generate a free radical. From that free radical, we will have different free radicals. Because of this mechanism, what you will see, this will attack on the more number of hydrogens, right? Okay. In HCl and HI, it is not applicable. This mechanism is not applicable in that. Okay. Yes. Not homolysis, but yes. As you can see here, I'll tell you, just give me a second, right? Just give me some like time, okay? Now, as I told you, with HCl, it is not possible. Reason is, it is interesting to know that anti-Markovnikov is not possible. Peroxide not applicable for HCl and HI. Reason of HCl is the energy here, right? So, as you can see here, it is an endothermic reaction. Energy is required in this case. To break this bond as free radical, we require the energy. That is why whenever energy is required, that reaction is not preferable. That is why this is not valid. As if you talk about HI here, this is basically endothermic only. But here one more reason is that, but in the case of HBr, both steps are exothermic, which results in the spontaneous reaction. Okay, understood? Yes, guys. So, but in case of HBr, both are exothermic. That is why spontaneous reaction happens in this case. Okay, understood? Yes, everyone. Yes, Jayata, understood? No. Now that was what is the number of that? Fourth. I think third. Okay, this is the fourth one, hai na? Fourth. This is fourth question. So, fourth is addition of sulfuric acid. So, when you are adding sulfuric acid, simple, this H positive it will lose and you will have, with the oxygen linkage, you will have OSO3H linkage here. Here also you will have, this is OSO3 linkage. Okay, so you will have this linkage here, the simple compound, this is never asked. Okay, so I'm just not giving it any importance, right? Next is addition of water. Now this is a very important reaction, highly asked, right? Reason I'll tell you why this is highly asked. This is highly asked. There are few reasons, because there are three ways. One is acidic hydration, other is hydroboration oxidation, third is demercuration, oxymercuration, demercuration. In all these three things, different products are formed. Focus on the products, okay? Focus on the products. Acid catalyzed hydration of alkenes. It will give you which thing? Acid catalyzed hydration of alkenes. It will follow Markovnikov rule. Markovnikov rule, but I will not write it as Markovnikov. So I'll just erase this in the notes as well. Right? Why ma'am is erasing in the notes? Anybody in the chat box who can tell me the reason? Who can tell me the reason? Here strictly Markovnikov rule is not valid. Here firstly carbocation will be formed. Then rearrangement will occur. This is very strict thing, okay? Very strictly, they can easily ask you question based on this. Then you will have the product. Then you will have the product. Addition of water simply means that OH and H positive will be attached in the double bond. Right? So here, because this is not a complex compound, that is why break this bond and attach OH and H here. Right? Now this is unsymmetrical. We know that Markovnikov means negative to less number. But I don't want you to have the habit of Markovnikov. So what we will do? First we will break this bond, that is CH3, C, this is CH2. Right? This will be negative and positive here. Right? Can you tell me why here we have positive? Why I have not made it like this? Why it is not positive here, negative here? Anybody in the chat box who can tell me the answer for this one? Anybody in the chat box who can tell me the answer for this one? Why it is so? Inductive effect. Because here, due to inductive effect, this carbocation is getting stable. So that's why when you will have this, when you will attach one hydrogen already here, right? When you will attach one hydrogen already here, but when you attach hydrogen here, you will get this kind of compound. Now, this is giving it more inductive effect from two sides. Here it is inductive effect only from one side, right? That is the reason. Very good. Carbocation stability. That is why this is not preferred, this is preferred. After this, always use this thing. You will always get the correct answer. If you just randomly you write positive, negative anywhere, you will get the wrong answer if they give you any complex molecule, right? Okay. Now, then add oxygen there, simple. Just add oxygen here. OH. Wait a minute. Wait a minute. It should be CH3. It is CH3 also here now. CH3 also. So, definitely this is more stable. So, definitely this is giving, it is tertiary. It is primary, right? So, after this, what you will do? Add OH here. So, it will get CH3, 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 then OH. Right? Okay? Understood? Very good. Carbocation stability. Now, okay, this is not given here, but will explain you that. So, addition of water is basically three processes, right? One is this one, other is this one. Wait a minute, I'll just write here. The second process is addition of water is hydroboration, oxidation. Okay. The third process is oxymercuration, demercuration. Just simply I am writing here. In hydroboration oxidation, you use anti-Markovnikov, directly use anti-Markovnikov rule. Here, directly use Markovnikov. I am telling you. You don't need to make any carbocation here because in this mechanism, there is no formation of carbocation. It occurs via transition state. So, you need to directly apply Markovnikov rule here. Directly. Markovnikov directly. No carbocation. No carbocation here. Understood the difference? In all of the three cases, we will add OH and H. But in this case, in this A part, We will add acidic hydration. Acidic hydration, which occurs by carbocation, then rearrangement. Right? But hydroboration oxidation anti-Markovnikov. Now, just take an example that you have CH3, CH, this is CH3, double bond, CH2. Here, when you hydroboration oxidation means B2H6 and adding H2O2 here, right? This question has been highly asked in your JEE, right? This is a very, very important reaction of JEE, right? Now, here, anti-Markovnikov means OH negative part. Negative OH, negative part is to the less number of hydrogen. So, this will be CH3, CH3. This is OH, this is CH3. Okay, understood? Understood? Okay, guys, understood or not? Everybody? Everybody? Okay. Acha, what about this one? If you do the same thing here, so it will be CH3, CH2 double bond. Here, if you add oxymercuration, demercuration, this is basically HD. I'll just write the full reactant here. It is AC twice. AC twice, basically it is acetate only. Twice AG, HG, oxymercuration, then demercuration. Demercuration, we use NaBH4 for demercuration. This is mercuration part, this is demercuration part. This happens via transition state, right? So here, negative part 2. Wait a minute, this is opposite, no? Wrong. Anti-Markovnikov means negative part 2, more number of hydrogen. So answer will be CH3, CH3. This is CH2, this is OH, and this is H. This will be the correct answer, right? Negative part 2, more number of hydrogen. Negative part 2, less number of hydrogen. This is CH3, this is C, this is CH3. Negative part 2, less number of hydrogen. It has less number of hydrogen. So this is OH, this is CH3. So mostly, in most of the cases, oxymercuration, demercuration and acidic hydration, they will have the same answer. But follow this. Here carbocation, then rearrangement. Here directly apply the Markovnikov. Okay? Yes. By anti-Markovnikov. Oh, yes, ultra, you are right. My mistake, my bad. Right? Okay? Now, 2-3 more reactions we need to do here. So they are talking about oxygen, ozonolysis, then polymerization. Acha. 2-3 reactions. Let me write it myself only. Acha. That is before oxidation we will write that. Right, before oxidation we will write that. Now, here we have, let us firstly talk about hydroformylation. Okay. This is 4, I think this is 6th. Hydroformylation. Can you tell me what is formylation? What is a formyl group? Everybody, what is a formyl group? Everybody, what is a formyl group? What is a formyl group? So you have a alkene, right? You have a alkene. Here, if you are adding carbon monoxide in cobalt at a temperature, let me write the temperature, 150 degrees Celsius. Basically, you are using water gas here, right? So that is, water gas is carbon monoxide plus H2. Water gas you are using here, and you will have the addition of formyl group from here. From here, as it is, CHO group will be attached, right? This means this is your RCH2. Wait a minute, why we have not made double bond here? 1, 2, 3, 4. Okay, this double bond will break. Here you will have the addition of hydrogen, and here CHO group will be attached. That is formylation. Okay, CHO group will be attached. Now here it is not selective at all. It can form, it can add H here also, here also. If hydrogen is added here and CHO is added here, so both the products can be formed. Right, both the products are the equal composition. CHO can be here or here also. This is called hydroformylation reaction, a very simple reaction. Okay, understood? Yes guys. Now let us do one more reaction, that is Tidden's reaction. Tidden's reaction. Okay, Tidden's reaction. Tidden reaction. This is basically adding NOCl here, right? Okay, adding NOCl. So let us see the full-fledged reaction. Okay, so let us see. You have this is CH double bond CH2. You are adding NOCl here. NOCl you are adding, right? And what you are getting here? This is R, C, C, H, this is NO, and this is Cl. This is what you are getting. Okay? Okay. And one more thing to remember, that there is anti-addition, so you can write it as this. Okay? Yes, everyone? So these are like very small reactions. They can ask you, like if they ask you these kind of reactions, they will ask you directly only. Right? Directly only they will ask you these kind of reactions. Okay? Understood? Everybody? Everyone? Now we are left with 2-3 more things. Addition reactions we have done. Now what are the oxidation reactions? What are the oxidation reactions? Hanji, what are the oxidation reactions, everybody? Guys, I think someone is calling me. Just give me 2 minutes. I'll be back in 2 minutes, okay? Okay, everybody, I am back. I am back. Okay, now let us see. Directly, I'll tell you what we need to do. Okay, there are two type of reactions, oxidation and ozonolysis. I'll give you a simple trick on that. Okay, ready for the trick? Okay, so I'm going to give you a simple trick here. Right? Okay, let us see the trick. Okay, let us see the trick. The trick is, if you are adding oxygen and this is KMNO4, let's delete all of this. Let's delete all of this. Let's do this with a simple trick that I'll tell you. Okay, chalo. Okay, firstly, to just see that what is ozonolysis, right? Okay, firstly, just see the mechanism, that will give you simple trick for oxidation and ozonolysis, right? So basically ozone is added here, right? And you will break the unsaturation and double bond O will be attached here. How it is attached? So it is a two-step process. First is ozonide formation, then decomposition of ozonide. So what is that? Basically, firstly, this is called ozonide. Firstly, you will have a hut type of formation of ozonide. Now, these bonds will break. These bonds will break here. These bonds will break. These three bonds will break, and you will have the formation of this double bond O. Now, these two steps you know. Now, what is a trick to answer any question here? Now, again, what they are doing? Again, ozonide is formed here. Again, this bond will break, this bond will break, this bond will break. You will have the formation of corresponding thing. Now, how to solve this directly? CH3, CH double bond CH2. Just remember, break the bond, attach double bond O, right? Break this bond. I'm just going to break it like this, okay? Break the bond, attach double bond O. This is CH3, this is CH double bond O. That means it is C double bond OH, right? Here also we are doing the same thing. Here also we are doing the same thing. Break the bond, attach double bond O. That means to this carbon, attach double bond O. This is H, this is H. This is H2C. This is basically nothing but this is HC double bond OH. Right? Okay. So, formaldehyde is formed here. Right? Okay. So, that is the same answer that we got. Okay. So, just break the bond, attach double bond O. Any answer you can give there. Break the bond and attach double bond O. Don't go through this. C double bond O. This is CH3. This is CH3. Plus. This is your CH2, this is C double bond O, this is H and this is H. We can also write it as HC double bond O and H. So that becomes a next answer. Okay, that becomes the next answer. Got it? Everyone, simple, right? Simple. Now I'll give you one more important case here, right? One more important thing. There are two types of ozonolysis. From this, most of the questions you will be able to solve, right? First is reductive, other is oxidative. For reductive, break double bond O. For reductive, the trick is break double bond O. Double bond O. This is the trick that I am telling you. Double bond and attach double bond oxygen. Here, first step will be as it is. That is break double bond O, break double bond and attach double bond oxygen. But here you will add one more step. Convert hydrogen to carbonyl. Convert hydrogen connected to carbonyl carbon to, or you can say just write it here, carbonyl carbon, okay? Carbonyl carbon to OH. Shall I now give you what are the reagents? Now we will do a question. Simply we will do one question and you will say that, ma'am, this is awesome, right? When you have O3 in presence of zinc, right? When you have O3 in presence of zinc, when you have O3 in presence of Me2S, it will give rise to reductive ozonolysis. When you have O3 in presence of H2O2, it will give rise to oxidative ozonolysis, right? Got it, guys? It will give rise to oxidative ozonolysis. Okay, everybody? It will give rise to oxidative ozonolysis. Right? Okay, everyone? Okay, everyone? Okay. So I'll just write it here only. Now, Now, the lecture is very long, but tell me how much content I have taught you here. Now, one more thing to remember, that answer will be same as oxidative ozonolysis. If you have hot or alkaline, you can say, wait a minute, let me just write it here. Hot concentrated KMNO4 or K2 or simply K2Cr2O7, because K2Cr2O7 is a better oxidizing agent. Okay, this will give rise to oxidative ozonolysis answer, right? Okay. Here if something directly dilute KMNO4 is written, if dilute KMNO4 is written, the answer will be same as, see, listen one thing, this thing is called oxidation, that is called ozonolysis. I am just telling you that the products will be same in both the cases, right? Even if you have this kind of ozonolysis, even if you have this kind of oxidation, right? Okay. Now I'll give you one question here. Acha, let's do Beer's and Wecker's process here, right? Chalo. Now, let us do one thing here. Okay, let's do one thing here. If they ask you the answer of this is reductive ozonolysis answer, oxidative ozonolysis will be equals to, replace this H with OH. So it will be CH3 C double bond O OH plus, here replace this H and this H with OH. So it will be C double bond O, this is OH, OH. Now what is this acid? This is nothing but H2CO3. So H2CO3 is usually converted into water and carbon dioxide. So you can also see the answer as H2O and carbon dioxide. Okay, because it is usually decomposed into water and carbon dioxide. Same if you want to see the answer here. The answer for oxidative ozonolysis will be, here you don't have, no hydrogen is attached to the carbonyl carbon, so it will stay as it is. It will stay as it is. But this H and H will be converted to OH. Hence you will have H2CO3, because if you convert this will become C double bond OH, OH, that is H2CO3, and that will be written as H2O plus CO2. Right? Got it? Got it, everyone? Everybody? Got it? Two more processes you can write here. That is Wecker's process. Firstly, write Beer's reagent. So what will happen with Beer's reagent? If you have cold dilute alkali KMNO4. Okay. Cold dilute alkali is 1%. In this case, if you have alkene, what will happen? So just imagine you have this kind of alkene, pi bond will break, and this is the reagent that you will have. OH will attach on both sides. OH here, OH here. Again, this is test for unsaturation, because the pink color of KMNO4 will disappear, right? This is of pink color, this is of pink color, this is colorless, this is color, basically pink color disappears. Pink color disappears. So this is also the test of unsaturation. This is also, you can write the test of unsaturation. This is also the test of unsaturation. Okay. Okay. You can also write one thing that a byproduct is brown color of PPT is formed, right? Brown color of PPT, you can write here that brown color of this, not this, but the brown color of PPT will be formed of MnO2 and glycol, right? Okay. If you want to write it, you can write of MnO2 and glycol. Okay. Next is Wecker's process. That is the last reaction here. Wecker's process. Can you tell me what is this Wecker's process, anyone? What is Wecker's process? See, you have a alkene. Let us say you have this thing. Add PdCl2, add CuCl2. Pi bond will break and this will be converted to CH3CH2. But that same thing is converted to a CHO, right? So that is called basically Wecker's process. Okay? Okay? Understood? Understood? Peroxide is added here. So these reactions, if they ask you, they will ask you directly only. This they can ask you in the test of unsaturation. This they can ask you given you different reactants and asking you the products. Okay. Now, last is polymerization. After that, we will start the questions. Okay. Let us see the polymerization. Polymers are high molecular mass substances consisting of large number of repeating structure units derived from simple molecules, right? So polymers, they can form, if you have seen polymer, like polymerization reaction, basically like PVC, polyvinyl chloride, right? Rubbers, natural rubber, synthetic rubber, all these are this Teflons, all these are basically polymers only. Polythene, this is also a polymer of ethene, right? So all these are polymers of alkenes only, right? So you can see here, like you have polythene, this is a polymer of ethene. You have polypropene, this is a polymer of polypropene. Okay. Chalo. Now let us do questions, right? Okay, let us do questions. First is the final product E formed in the, now the one who has studied like in detail, in depth, he has kept the patient, he or she has kept the patients, then I think this will become really easy for you, right? Okay. The final product A formed from the following reaction sequence. First is you have PHCH double bond CH2. Now, when you are doing hydroboration oxidation, this is nothing but hydroboration oxidation. Here we used anti-Markovnikov product. Right? These are all your previous year questions only. So, anti-Markovnikov means OH negative to more number of hydrogens. That means this thing will be formed. After this, you are adding HBr. Alcohol with HBr, it is going to replace the OH here. It will be PH, CH2, CH2. This is Br. Now they are saying with MgBr. MgBr, what will happen? Guys, very interesting. With Mg, what will happen? Mg, after Mg, it will be pH, CH2, CH2. This is basically when Rx is reacted with Mg. This also we have done today. So, Mg will attach in between this side. So, it will be MgBr. Now, with this MgBr, you are adding HCHO. That means this thing you are adding here. Right? So this is the question. pH, CH2, CH2. This is MgBr, MgBr. Here you are adding HC double bond OH. Guys, we have done this like so many times. This is positive, this is partially negative. This is partially positive, this is partially negative. That means what will happen? This will attack here. This will attack here. So what will happen here? What you will get? CO negative. This is H2. It will get attached to this carbon, which is having one CH2 and one PH. This is getting attached to this carbon that I have shown you here, right? Okay. Now we know that to this O negative MgBr will be attached. After the hydrolysis, this MgBr is converted to OH. So that is the final product that you will have. Okay. That is the final product that you will have. Okay. Hana? That is the final product. Are you guys able to understand? PH CH2 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 OH. PH CH2 CH2 no. PH CH no. PH CH CH no. PH CH2 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 OH. Fourth is the correct answer. Okay. Easy. Easy peasy. Hana? What we have done? Wait a minute. What we have done here? Hydroboration oxidation, anti-Markovnikov, adding HBr, OH will be replaced by Br. Then Mg, attach Mg here. Then we are having this kind of reaction. Right? Okay. Okay, guys. Next question is, identify product A and B. Array, I forgot to tell you this thing. I forgot to tell you one question. One substitution reaction I forgot to tell you. Let's write it here. I forgot to tell you one very important substitution reaction. Substitution reaction. That is, always remember, if you have a alkene like this, let's say CH3, and by the help of example, I am telling you this. If you are using H mu and Cl2, and if you are using CCl4 here, okay? So there are two ways, okay? CCl4 only we are using here, right? Wait a minute. Okay, if you are using CCl4 and Cl2, wait a minute. Two things can happen, and from this also you can see your JEE question. If you're adding Cl2 or Br2 in presence of H mu, you're adding Cl2 or Br2 in presence of CCl4. In presence of CCl4, we have done this reaction that double bond will break, right? And this is double bond will break and you will have the addition of vicinal dihalides. Have we done this reaction? Have we done this reaction or not? Have we done? Then do something so that I can also love you. You're doing things which makes me hate you only. JEE 2025. Now, break this double bond, you will have the formation of vicinal dihalides. But if you have a Cl2H mu, this will give you substitution reaction. This will give you addition reaction. Here, allylic carbon will be substituted. That means this CH2, Cl, and here it will be CH, this will stay intact. Double bond will stay intact, but allylic carbon will be substituted. Right? Okay. Allylic carbon will be substituted. Okay. Yes, everyone. Now, what will happen in this reaction? You have two things. First is in the presence of H mu, allylic carbon will be substituted. Allylic means this carbon and this carbon. Here hydrogen will be substituted. So that means this can be the correct answer, this can be the correct answer, this is wrong and this is also wrong. In CCl4, double bond will break. That means definitely this is not the correct answer. Double bond will break and ClCl will be added here. So vicinal dihalides will be formed here. Right? Okay. Okay. So answer is fourth is the correct answer. Next is very important, as I told you here, O3ZnH2O. This is reductive ozonolysis. That is why they have asked you this question. Reductive ozonolysis. So what will be the answer? Break this double bond, attach, break this double bond, attach double bond O. CH3, this is H, this is double bond O. Break this double bond, attach double bond O. This is C, double bond O. This is H and this is CH3. Okay, so that is going to be the answer. So, consider the given reaction, total number of oxygen atoms present per molecule in the product. Per molecule, you have one oxygen atom. So, answer will be 1 is the correct answer. Okay, 1 is the correct answer, right? Okay. Next question is, product A and B formed in the following reactants are. Have we done this? This is by carbocation formation and rearrangement, acidic hydrolysis. This is anti-Markovnikov rule, right? Anti-Markovnikov rule, right? These are all your previous year questions, guys. So B will be equals to, when you apply anti-Markovnikov rule here, then this double bond will break, and anti means a negative part to more number of hydrogen. More number of hydrogens are present here. So it will be break this double bond, OH will come to this side, CH3 will be present here. This is your answer for B. What about A? What is the carbocation? The carbocation formed here will be, this is your double bond will break. Definitely positive will be present here. Why? Why? Because more stable. Because of this inductive effect, it will be more stable. If positive is here, then it will be less stable. Here, positive is more stable. Right? Now, this is more stable. Now, you add OH here. So, OH will be added here. So, answer will be CH3OH. This will be the correct answer. So tell me, from this, which is the correct answer? A is this, B is this. So second will become the correct answer. Right? Okay. Okay, guys. Okay, next question on your screen. The product C in the below mentioned reaction is. Okay, so chain reaction again. Alcoholic, this is basically they are writing alcoholic, and here it is written dilute, and here they have written aqueous. Okay, here they have written aqueous. Now tell me, simple question, okay, very simple. When you have alcoholic, that means dehydrohalogenation will occur. So A will be, it will be CH3, CH double bond CH2. This is your A. After this, you are adding HBr into this. When you add HBr into this, HBr simply it will follow Markovnikov addition. Br will be added to negative, less number of hydrogens. Br will be added to less number of hydrogen. Or you can just write it here. Br will be added to less number of hydrogen. Answer will be Br here and CH3 here. Then you are adding KOH aqueous. KOH aqueous is going to replace Br here. So answer will be CH3, CHOH, CH3. That is propane 2-ol. So fourth will be the correct answer. Fourth will be the correct answer. Okay? Fourth will be the correct answer. Understood? Understood, guys? Okay. Next is, I don't feel you guys look very excited about the question. Where is that excitement? Where is that excitement? Huh? I thought you will just reply like this. Okay, ma'am, we are waiting for the question. Huh? Try to answer. Even if you answer wrong, try to answer. Okay? At least try. Okay? When you try, it will stay in your head. Right? It will say, okay, ma'am has taught that I got the wrong answer, but then ma'am corrected me. Right? That will stay in your head. Major product of the following reaction. See, basically HX is a anti-reaction. For this also, I think, I don't know if I mentioned that or not. This is an anti-addition. This is an anti-addition. For when this double bond will break, it will be anti to each other. Right? It will be anti to each other. Anti is this one and anti is this one also. But this CH3 will not change its position. CH3 will stay as it is here only. It was here before, so it will stay here only. But Cl and deuterium will attach here. Now guys, one more thing to remember, that I think that will be added on the same side, because number of hydrogen are very less. This is positive, this is negative. Negative is attached to less number of hydrogen. Less number of hydrogen are present here, right? So that means Cl is attached here. Cl is attached here. Okay. Guys, third will be the correct answer, right? Cl is attached on this position and anti to it deuterium is attached, right? So answer will be third is the correct answer. Okay. Markovnikov rule, anti-addition I was talking, anti-Markov, it follows Markovnikov rule only, but addition will be on the opposite side. Okay? That's by Markovnikov, so answer is C. Okay? Yes. Now, so answer will be C is the correct answer. Next is what we have here. It's a good question. They are asking you the value of A and B. So firstly, can you see one thing? When you break this bond, what will happen? What you will get? If you break this bond, you will get double bond O here. You will get double bond O here. Isn't it? But here you can see one more thing. This double bond O and this will be one hydrogen. So can you say this thing will be formed as double bond O? Or you can say this is double bond O. Wait a minute. This is one benzene. If I take the carbon here, okay, this will be double bond O and this will be hydrogen. Yes, the same thing. It's just a rearrangement we have done. See, this is the benzene. When you break this double bond, hydrogen is here, double bond O here, and one hydrogen here. It's just the rearrangement they have done. It can also be written like this. This is benzene. We can also write it like this. Double bond O here and H here. And here we can write, and here also we can write it like benzene. One carbon on this side, double bond O here and H here. It is just a rearrangement that we did, right? It is just a rearrangement, right? After it, that means definitely we are using ozonolysis. So this is not the correct answer. This is not the correct answer. Here we are using ozonolysis, right? That too reductive ozonolysis, right? After this, what we are doing? Very good, simple. Tell me in the chat box, right? Right. Now, here, very important thing. KMNO4, if we had given it KMNO4, then this hydrogen would have converted to OH. This would have converted to OH, right? But this is not happening here. So, definitely this is the correct answer. So, that is a hint. Now, this is basically a not wait a minute. This is NaOH alcoholic, right? So, when you have NaOH alcoholic with I2, so this H, okay. So basically, when you are adding NaOH alcoholic and I2, what will happen here? This H is replaced by ONA, right? This is basically the oxidation will happen in this case. The oxidation of this particular compound, this particular group will happen in this case, right? Okay, so answer will be very good. So answer will be second is the correct answer. Okay, so second will become the correct answer, and after that CHI3 will be formed, hai na? Yes. Okay, so answer will be second is the correct answer, right? Okay. Huh. Now next is consider the given chemical reaction KMNO4 H2SO4 and heat it. Achha, see KMNO4 H2SO4, here this is basically the product of oxidative ozonolysis. Same as oxidative ozonolysis. Same as, that means break this bond, break this bond, break this bond and attach double bond O, attach double bond O. This is one hydrogen here, one hydrogen. Then convert this hydrogen and this hydrogen into OH and OH. Right, so basically this is your, this is your COOH, this is COOH. So 1, 2, 3, 4, 5, 6. When you have 6 carbons and in the end you have COH, that is called adipic acid. So answer is C is the correct answer. Third is the correct answer. Okay. Yes. Identify the product A and B. Now identify product A and B in the following set of reactions. See. If you identify the product A, what will be the correct answer? Let us see. Product A is basically, this to we have done na? Acha, that was the same kind of question but with a different reactant. This is very simple. So here what will be formed? Very simple. This is your homework. Very simple. I am not going to solve it. Right? Write this in the comment section. Okay, after this video I will see how many of you write the answer, whether it's 1, 2, 3 or 4. Here make the carbocation, then attach OH and H. Here this is anti-Markovnikov. Okay, this is your homework. Very simple question. Oops, 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 oops. Oops. I don't know if you have seen this or not. Okay. I'll still erase it. Okay. Huh. Now, next is number of CH2 methylene groups in the product formed from the following reaction. Okay. Okay. Good question. Okay. So, basically, when you do the ozonolysis, this bond will break. That means you will have this kind of structure, right? Then when you do KMNO4, when you add KMNO4 into it, this hydrogen is even replaced to OH. This hydrogen that was initially present here, this will be replaced to OH here. Then you add NaOH. When you add NaOH, this will be replaced by Na. Then you do electrolysis. When you do electrolysis of this, what will happen? Kolbe electrolysis. This is your R part. Double of this thing will be formed. 1, 2, 3 carbon it is having. 1, 2, 3, 4, 5, 6. 6 carbon ring will be formed in Kolbe electrolysis. Right? Okay, unfortunately you saw it. Kolbe's electrolysis. Right? Kolbe's electrolysis. Then they are saying, can you tell me what is this reagent? How this is used? Anybody in the chat box? Anybody in the chat box? Anybody in the chat box? What is this thing called? This reagent is used for aromatization. Aromatization, right? So here, what you will have using this thing here, 6-membered aromatic ring, that is benzene, will be formed. And in benzene, you don't have any group which is having CH2 single bond because it is CH, 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 CH. Basically, all the carbons will have HH, not 2H. So all the carbons have 1 hydrogens, okay, 1 hydrogens. So there is no group carbon that is having 2 hydrogens here, right? Okay, so answer will be 0. Okay, okay. Even if they use potassium dichromate, even then the answer will be same. Okay, understood? Thank you, Vijay. Okay, understood? So answer is 0 is the correct answer. So answer is 0 is the correct answer. Okay, 0 will be the correct answer. Okay. Next question is, in the reaction, of this is a very, very important question. Okay, this is a very interesting, nice, good question. Okay, wait a minute. I think this is the last question. Okay, this is a very, very important question. Because, see, I'll tell you the answer also. This is 8 or 11. This is the interesting part here. Why 8 or 11? I'm already giving the hint. Why 8 or 11? Let us see that. See, you have this thing, O3 excess and then ZnH2SO4. Can you say this is reductive ozonolysis? This is reductive ozonolysis. See how many questions they are asking from ozonolysis, right? That means break these two bonds, attach double bond O. So this is pentane ring, right? This is octane ring. Okay, I'll just draw it as it is. 1, 2, 3, 4, 5. Okay, now let us see this thing here. This bond we will break because pi bond, because this double bond will break, and you will attach double bond O here. See this very carefully, guys. Attach double bond O here, attach double bond O here, attach double bond O here, attach double bond O here. Right? Now add NH2OH in excess. NH2OH in excess. That means this will be double bond O will be converted to NH2. Sorry, not NH2. This is NHOH. How this happened? Do you remember this reaction? In aldehyde ketones, we have discussed C double bond O, and this is NH2, which was NH2Z. So what we used to see that water will eliminate and the answer will be CNZ, double bond here. Do you remember this reaction? Guys, do you remember that reaction in aldehyde and ketones? See, it's a combination, right? So that's why this question is very, very important and a very good question. I think that chances are most of the students will answer this incorrect only, because even after they know this thing, chances are they will answer it incorrectly, right? So here, can I say that if I want to draw it in a more zoomed version, if this is my octane, this is 1, 2, 3, 4. Okay, this is again 1, 2, 3, 4. Okay, I'm just drawing it in a zoomed version, right? This double bond O is replaced by double bond NZ, double bond N. And what is Z here? What is Z? This is NH2OH. So Z is nothing but OH. Z is nothing but OH here. Can you see, guys? Please tell me in the chat box if you are able to understand this or not. Otherwise, I will to teach myself only, right? So this is NH2Z. So Z is OH here. So this will be NOH, double bond NOH. This will be again double bond NOH. This again will be double bond N. Let me write it here. Double bond NOH. Are you able to understand this or not, guys? Okay, is that clear? Till here is everything clear or not? Till here is everything clear or not? Till here is everything clear or not? Because after this, more important thing will do. Like one more important thing. This is the last question. After this class, after this question, the class will end. Okay. Now, I'm going to draw this question, this thing again here. I'm just copy pasting this thing. Chalo, I'll draw this on a blank slide only, right? So wait a minute. What you have? You have this thing. Right? Then you had one bond above, one bond down here, one bond here, one bond here, one bond above, one bond here, one bond here, one bond here. Okay. Now this is your, see, I'll tell you that what we will do here. This is N, this is double bond NOH, this is double bond NOH, this is double bond NOH, this is double bond NOH. Now guys, they are asking you the sp2 hybridized atoms. First is, this carbon is sp2 because it is having 3 sigma. This carbon is sp2, this carbon is sp2, this carbon is sp2. That means 4 carbon are sp2. Right? How many nitrogens are sp2? Nitrogen is forming 1, 2, and there will be one lone pair also. Whenever nitrogen is forming 3 whenever nitrogen is forming 3 bonds, it is having one lone pair also. So nitrogen is also, 4 nitrogen are also sp2. That is why they have written 8 here. That is why they have written 8 as the correct answer. But now I am copy pasting this thing again. Now what we will do? Now we will see the resonance here. Now we will see the resonance here. Okay, how resonance is going to impact it. How resonance is going to increase the number of sp2 hybridized bonds here. So what will happen? This is lone pair. It is having lone pair. It is having lone pair. It is having lone pair. Because of that, this bond, this lone pair will shift here. And these bonds, wait a minute, these bonds will shift here. It's having one positive, one negative. Wait a minute, wait a second. This will be having one negative here, no? Just give me a second. So this bond will shift here and this pi bond will shift here, right? So now what will happen? I'm just drawing this here. This is the bond that is going to shift here. New bond will be formed because now it is having 3 bonds, so it will be positive. Now this carbon will have a negative charge because this pi bond will break here, right? So it will be like this. It will be like this. This is carbon. This is a nitrogen. Pi bond will shift here. That is why it will adapt a negative charge here. So if I can show you the transformation, this is basically, this bond is shifting here. This bond is shifting as this negative charge. So basically this will have negative N double bond O positive. So all of them will have the same thing. So I'm going to draw the same thing here. Everywhere same thing will happen. So here it will be again N double bond OH, N double bond OH, again here N double bond OH. We know that oxygen with 3 bonds, it is positive, positive, positive. This is negative, negative. Now see, can you see one more thing here? Now in this structure, carbon having the sp, so basically if you talk about the carbon that are the same, right, having the sp2 hybridization. But if you talk about the oxygen, can you see this thing here? Can you see this thing here? Now oxygen is having hybridization what? This oxygen is having only 1, 2 sigma bonds, and one lone pair over here. One lone pair over here. One lone pair over here. So now oxygen, 4 oxygen is having sp2. That means total 12 12 atoms are having uh, sp2 hybridized carbon atom. sp2 hybridized sp2 hybridization. Right? Okay? Understood? Okay. Okay, guys. Now, the answer that you will have, that is why the answer is 8 or 12. Right? That is why the answer is 8 or 12. Okay? 8 or 12. Got it? Chalo. Okay then guys, bye bye, take care, see you all in the next class. And in the next class we are going to take up more questions because we are going to do alkynes and aromatic hydrocarbons. Okay, bye bye, take care, see you all in the next session. I am going to provide you notes on JEE channel, JEE Telegram channel. Okay, bye bye. This was crazy? Yeah, it was crazy. Okay, bye bye, bye bye. Good night, bye bye.